All right, so Unit 9, this is the second to last unit. The remaining unit is advanced alignments, some other advanced vehicle features, and like advanced driver assist. So as far as really the meat and potatoes, as you say, go, this is going to be the final unit to get ready for that ASE. So without any further delay, let's jump into it. Steering systems. Okay. So as you already knew, probably, the steering system provides left to right movement of the tires, and it's controlled by a steering wheel. So you're moving the steering wheel needs to move the tires predictably, reliably, and it's very closely related to suspension. So when we're moving the steering wheel, we're actually also moving suspension parts. They kind of work together. And then another thing is there's a lot of components installed between the steering wheel and the wheels. So you need to know all those components and they can vary. So let's say it's a steering rack system. There's certain components, but if it's a steering box or they'll call a parallelogram, there's totally different components. So on this ASE, they're going to ask you questions and you have to be familiar with the parts that are in the system and what they do and what the symptoms might be if there's a problem. All right. And then look at this power. I'm supposed to yell that. Power steering is the system that provides the assist. So we're going to first start with the linkages and the gears and the parts. And then because it's kind of complex, and then we'll add power to it later. And then power steering can be hydraulic. That means power steering fluid and a pump, or it can be electric. And I put electric slash electronic because it depends on how you look at it. Electric is like more power. So power equals volts times amps. So it's either going to be higher voltage or higher amperage, probably mostly amperage. That does work. So it's electric. But what controls that is really electronic. That would be sensors, control modules, um, logic, some of the stuff we covered with ABS, same type of thing for um, electronic power steering and even hydraulic too. And there's one more that's a blend between these two. I got like one slide on that. So, and then of course, there's always been a mechanical connection between the steering wheel and the wheels and tires. So, if you're moving the steering wheel, you're physically moving something which is moving the wheels and tires. And that is traditional. But what I said here, that's no longer necessarily true. So, the reason I bring that up now is Lexus came out with the RZ 350. And on that vehicle, not all of them, you can buy one with a regular steering wheel and linkage, but you can also buy one with a yoke, which is more like a Tesla, like a new Tesla Model S Plaid yoke, where you don't turn it hand over hand over hand. You just turn it like this. And that's like as far as you have to turn. So on that new RZ 350, if it has the option of what we call drive by wire or steer by wire, actually, um, there is no connection. Your yoke is signaling a sensor, and that's it. And the sensor is signaling the computer, and the computer is controlling the electric power steering rack. So it's kind of crazy because 99% of this presentation is on these systems that we've had, for 100 years, and they've changed a little bit, but there's a chance, and probably a pretty good one, that a lot of this stuff is going to become obsolete really quickly. And as we get a little further in, I can explain to you why it's going that way and the driving forces and some of the benefit for that. Okay, so if you look at components, take a look at these components here, right there. We've got, we'll start with our tire and wheel right there. You're all familiar with that. That is going to bolt to your hub and your hub is going to be attached in some way, most likely through a wheel bearing, and that can vary by design. That wheel bearing is going to be attached to the knuckle, right? So the knuckle is a big player in this game. And the knuckle, sometimes they may call stub axle, depends on what type of vehicle it is, but that that knuckle is going to be sitting on our upper and lower ball joints, or a lower ball joint and a strut. And so we'll cover that a little bit more later. But you can see quickly how the steering starts to overlap with the suspension. So those were quite a few suspension terms. Then from there, that knuckle has a steering arm attached, as you can see right here. And that steering arm is something that we're going to focus on when we get into steering geometry, which you have to at least understand. You don't have to be a total expert, but you have to at least understand some of the theory. Then that steering arm goes to your outer tie rod or your tie rod end. So we'll jump over to the right side here. This is where it's really steering parts, right? So up to this point, everything I've described is part of the steering system, but it's also part of the suspension system. So it's kind of part of both, right? But from here, beginning with the outer tie rod end, that's steering, period. Outer tie rod end goes to this other part they call the tie rod, which goes to this other part they call the inner tie rod. And this is on one specific design. So this isn't true for all designs, but it's true for this one. The tie rod is basically a turnbuckle design. What a turnbuckle is, you have this tie rod, and one of these threads is a traditional clockwise thread, and the other one's reverse. It's counterclockwise. So a left-hand thread and a right-hand thread. And so as we turn that tie rod, it can actually make the length longer or make the length shorter. And that's pretty much what we do with the rack and pinion. So if you think about it, if you're turning the tie rod, let's just say it's hard to say clockwise or counterclockwise, because if I'm clockwise this way, but I'm looking at it this way, now it's counterclockwise, right? So let's just say you're turning it down. If you're turning it down, that's either going to be spreading both of the tie rods apart, or it's going to be pulling both of the tie rods together. Now, if you look at where this knuckle is in the steering arm, if you're spreading it apart, that's going to push this steering arm and knuckle outward, which is going to give you that toe in the front, right? So that's why we use that tie rod design. And then from there, that's how we do the adjustment for an alignment. But when we're actually going to steer, we're going to do something a little different. We bolt that inner tie rod to a lot of times what we'll call this is like a center link, or in this case, we could call it a track rod. So that's one thing that's kind of funny about steering suspension. We'll have different names for something that's almost the same or pretty similar. So to me, I like to call it a center link, because when I went to the parts department and I ordered this part, we called it a center link, and they knew what I was talking about. But in this case, fine, we'll call it a track rod. The track rod basically takes that tie rod end, that inner tie rod, on both the right inner tie rod and the left inner tie rod, and it attaches it to one common bar. And then that common bar is the track rod. That attaches this thing called the pitman arm. And the pitman arm is actually splined into the steering box sector shaft. So you're like, oh my gosh, there's so many names and parts already. And there is. And I'm just letting you know, that's one of the challenges. And then it makes it even worse that on one vehicle, they'll call it one thing, and on the next, they'll call it something different. Okay, so bear with me. But if you figure that pitman arm is splined to the sector shaft, as that sector shaft moves like kind of up and left or down and left, it's turning like a big circle here. As that moves, it's actually going to start pulling that track rod to the left or pushing it to the right. That's how we get our steering. But we can't have this track rod flopping in the breeze. So we tack another arm on there, and it's the idler arm. The idler arm doesn't really do a lot of work. It just kind of holds the track rod in place. It's sort of sitting there idling. It's idle. That's why they named it that. And so the idle arm's keeping everything in line. But as we want to move the sector shaft, what we'll do, we'll turn the worm shaft. So as we turn the worm shaft, it'll walk the sector shaft counterclockwise or clockwise, which will actually move the pitman arm, like my sweeping motion here, move it to the right, move it to the left. And that's really how this whole steering mechanism works. It's a little complex. There's a lot of parts. And I should specify we're going to start with this system simply because cars started with this system. I'm not covering things from most important to least important. We're kind of covering things as they came through with time, ending with the later things, right? So this is, you may say, old school. They did still use it on Toyota trucks till fairly recently, and even some Lexus SUVs. But from there, we could look at which types there are. So there's the rack and pinion or the parallelogram. Everything I just described was part of a parallelogram design. So that was the original. And since then, we've really gone more to the rack and pinion. So the parallelogram may be called a steering box. Found on trucks and SUVs, especially the older ones. Or if it's a bigger truck, like a Ford F-350, Super Duty, that's probably going to have a steering box. So those big heavy trucks have big old wheels and tires. We could make a steering rack for that, but we've made a lot of steering boxes in this parallelogram system, and we've already got a kind of design. And there is a little bit of little more to it than that. The parallelogram system does kind of isolate you from the road feel, and so when you're driving those big old trucks with the big old tires, you don't really want to get beat up. So a steering box is actually pretty good for those. And then, as I'm saying here, the rack and pinion is much more common, and it seems to be the future. And as we get to the end, you'll consider this and you'll realize it really is the future for several reasons. So here's your steering box. You can see what we were just talking about, some different names. We may call it the worm gear, but basically it can vary a little bit. So if we're looking at a steering box or a power steering rack, it's going to basically take a twisting motion from the steering wheel and turn into a racking motion side to side. The most concise way to do that would be a rack and pinion. However, we didn't start with that. All right, so we'll come back to some of these. If you look at these components, I think you're going to get a good idea as to which one you're starting to prefer. We've got this shaft right here, which is the pinion, and we're going to turn that with the steering wheel. And as we turn that, this is the pinion gear. So the pinion shaft and the pinion gear is on the shaft. As we turn that pinion gear, the rack is going to walk back and forth, right? So we're just walking it back and forth. As we walk that rack back and forth, notice the rack eventually attaches its way to that same steering arm, kind of like we looked at before. But you notice I didn't name a whole bunch of parts because the rack doesn't have anywhere near the parts that a parallelogram or steering box has. So we'll run through them really quick. Internally to the rack, we don't really worry about all the details in there because generally, if we have a problem in there, we're going to replace it with either a new or a remanufactured assembly. We don't go into, let's say, replace pinion bearings or an end bushing. We don't really do that. About as far as we'll go is the next piece off of the rack, which is the inner tie rod. The inner tie rod attaches to the rack. So when you're moving the rack, you're really moving the inner tie rod. And right there, that's a ball and socket joint, kind of like a shoulder, right? And like this shoulder for me is good. And this one, if I take it easy, it gets feeling pretty good. But then if I hurt it, it just, I lose all my strength. part of it is I damaged the socket here when I was young, and it's a little loose, and it tends to get a little bit of build up and stuff in there. So like if I do this, crack, 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 that's that concept is the same thing that can happen with this inner tie rod. The inner tie rod can get loose. The inner tie rod could potentially not be lubricated. So just like a ball joint, it's a ball and socket joint, and it lives right in there. It's very possible that those get loose. If those get loose, most people will sell a rack. They'll sell a rack and pinion. But that's not to say you shouldn't at least understand what's in there and understand that that's a loose inner tie rod and understand you actually can replace that, right? So right here, from here to here, this is all inner tie rod. When you're doing your alignment and you're spinning the 14 millimeters or 13 on that shaft and that shaft is spinning, you're turning the inner tie rod. The reason you can continue to turn that round and round and round and round is because it's on the ball and socket joint. This can spin indefinitely, no problem. But then that inner tie rod goes to the lock nut and then to the outer tie rod, or we'll call it the tie rod end typically. So then the tie rod end is going to have its own ball and socket joint, which can get loose, by the way. And that would go to the knuckle, which we'll call it specifically the steering arm part of the knuckle, right? And then we go back to suspension stuff, got upper and lower ball joints, etc. So there's your overall rack and pinion components. So compare that rack and pinion to, again, a parallelogram. There's just a lot more moving parts in the parallelogram. By the way, the reason we call it a parallelogram is highlighted here in yellow. So if you look, we have the center link for the track rod. If you like, we're just going to go with the center link now, okay? We have the center link, and that center link is always going to be parallel to where the base of the idler arm bolts and where the center of the sector shaft and the pitman shaft come together. So we'll say the anchor for the pitman arm and the anchor for the idler arm, those will be parallel to that center link, right? But then as you turn to the left, your pitman arm and your idle arm remain parallel as well. So that's why it's a parallelogram. See, if you're dead straight ahead, it could actually be a rectangle, but it's a parallelogram because these two always stay parallel and these two always stay parallel, even though the angles may change. So parallelogram design. All the parts we said, right? You've got your steering gear box, which goes to the pitman arm. The pitman arm goes to the center link. The center link goes to the idler arm. Both inner tie rods are bolted to the center link, which goes to the tie rod, which goes to the outer tie rods. So you have a lot more moving parts there. The pitman arm has a ball and socket joint on it that can get loose. The pitman arm goes to the steering gear box. So there's nothing that really fails there. But your idler arm also has a ball and socket joint, and a lot of times right here it has an idler arm bushing or sleeve where it bolts to the frame. So each of those points can wear. If each of those points has a little bit of looseness, you end up with kind of a lot of looseness. So if it's on this older style, there is a benefit. Like I said, it reduces road shock. So if you're hitting bumps and stuff, you don't feel it. It's not quite as, you feel a little disconnected from the road, which is good and bad. In a performance car, that's bad. You want to feel the road. In a truck with big tires hitting potholes, that's good. You don't really want to feel it. So positives and negatives. The other thing is, have you guys ever seen the old movies where, they'll have a camera and you're looking at someone driving the car and they're constantly doing this? You ever seen that? Right? Why are they constantly steering? Well, I can help you with that. New cars, we don't really have to do that. If you just hold the steering wheel straight, you're good. Older cars, they tend to get a lot of play. Play being like this. There's looseness between the joints. Now you have a lot of different joints on this parallelogram. So if you have a little bit of looseness, plus a little bit of looseness, plus a little bit of looseness, plus a little bit of looseness, you have a lot of looseness. So you're going down the road and you're, 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 your tires are going a little to the right, so you pull it just a little bit to the left, and that pulls them to the left, but then they're too far to the left, so you pull it back to the right. And so they just don't track really straight because there's a little bit of slop. And when you move the steering wheel, you can actually feel it. You can move the steering wheel quite a bit more on a parallelogram style where it's kind of loose, right? With a rack, it's fairly tight. There's not a lot of wiggle room, you may say. We'll call that play. So for better, for worse, these are the main types of linkages. Now we roll into suspension here. So I've actually rated these from the suspension presentation. So when we're turning, let's start with McPherson strut. When we're turning, we're using suspension components, and we're using that steering axis going way back to alignment, which was unit 7. So when we're steering the steering axis on a McPherson strut, let's say a Camry, the lower ball joint and the upper strut mount, that is the steering axis. Those are the steering components. So when we're turning, yes, we're using the rack, we're using the tie rod ends and stuff, but we're also interacting with the ball joint and the upper strut mount. If it's an SLA style, which would be like an older car or a truck, or we modernize it a bit. Let's call this a double wishbone, which would be very similar to this, but it probably wouldn't have a coil spring down here. It would have a coil spring strut design going straight through it to the frame, right? That's would be a double wishbone. The lower ball joint is the steering point, and the upper ball joint's the steering point. So your steering axis is upper to lower ball joint, right? So whichever type it is, remember when you're steering, you're rotating those parts. Let's say the double wishbone, you're rotating the lower ball joint, the upper ball joint. The reason this is so critical is some of the steering concerns we get are, the steering feels loose, or the steering it's hard to turn. It's requires high effort. One of the things you may hear on the ASE is a thing we call memory steer, which could also be called poor return to center. So you're driving down the road, you steer to the right, you let go, it doesn't return to center on its own. It kind of stays to the right. You have to pull it back to center. We could get really in depth on caster and SAI right there, but I'm going to start with it more simple. What if this lower ball joint right here was, it had a ripped boot and the grease leaked out and water and road debris got in and it corroded it? Now you have a rusty lower ball joint. You think the rusty lower ball joint is going to be easy to move or hard to move? It's going to be hard to move. Good. So if it's hard to move, the power steering's like, whatever, I got tons of power, I'll make you move. But then when you release the steering, when you're not pulling it back to center, the power steering doesn't do anything to help pull it to center. We're relying on the caster and the SAI to do that. If you have a ball joint that's got a lot of friction in it, it may have memory steer. It won't pull back to center on its own. Right? So that's true for a lower ball joint or an upper ball joint in this SLA short long arm, or the double wishbone. However, over here on the Camry, that could be a lower control arm, a lower ball joint. I agree. But it can't be an upper ball joint because it don't have one. Remember, the pivot point is actually the top of the strut, and that's that bearing that's in the strut. So if we had a corroded upper strut bearing, that could cause the memory steer or the poor return to center. Makes sense? So that's where you really got to see they do have quite a bit of overlap. Cool. So now about geometry. Basically the relations between the steering system, the steering wheel, the suspension, where the wheels are, it could be a little bit complex. So we call it a geometric arrangement. So when we're turning, the inner and outer wheels must trace circles of different radii. That means radius, but more than one of them. So like deer. If you see one deer, it's a deer. If you see two deer, it is not deers. It's just deer. Deer is plural. We could come up with other things, but radii will work, right? We're talking about more than one radius. Now we covered that once during alignments, but we'll go over it just a little bit more. If you're going around a circle, you actually would need both wheels shouldn't turn at the same rate. You're going around the circle, you'd actually need your toe out to increase as you turn. So dead straight, they should be the same. As you turn, you should get more and more toe out. When? On turns. Toe out on turns. So we're back to toot here. So toot was alignment, but it also kind of ties back into steering. So the toe out on turns, that's because you want both of those wheels perpendicular to one singular center point. So that way they're going around the turn, not dragging the outside wheel through it or something. Right. And that's actually tied pretty closely to the Ackerman angle. And that's to prevent scrubbing. So we can show you that in a couple different ways. But one, this is kind of showing you toe out on turns. Basically, your inner tire starts to turn a lot sharper than your outer tire, and therefore it's toed out. Right. If you look at that in another way, we've got your inner tire at 23 degrees and your outer tire at only 20 degrees. So there's a toe out on turn difference of 3 degrees. All perfectly designed. And if you were to, again, go ahead and take these and do a 90 degree, a perpendicular line off of those, they should all intersect when you're dead right in line with the rear wheels. So the center line of the rear wheels. This is going to be a perfectly executed turn with no scrubbing and no chirping and squawking and anything. So on purpose, all part of steering geometry, all built in, mostly controlled by the steering arm, which is generally molded in part of the knuckle. Cool. And then here's that Ackerman principle one more time. If you were to actually look at the steering arm on the knuckle, you should be able to pull a line off of that and it should intersect with the center line of the vehicle right where it hits the rear axle. So they've got all this geometry all figured out, all part of steering. When we put it on the alignment rack, yes, we can verify toe out on turns. Right? We just have to tell it we want to. And so that's kind of the point. And so rack and pinion steering linkage will be the next thing we cover because I feel like it's more simple. It's used on front wheel drive, rear wheel drive, all wheel drive, but it really started on front wheel drive. It's compact, it's lightweight, it's got a sharp steering response. You got a car that you want to feel sporty, you go ahead and you use a rack and pinion. That's going to be the best type of linkage for you if that's the feel you're going for. Cool. And then here's what it could look like cutaway. So this is the blue part is the whole rack and pinion body. This is the pinion that goes up to your steering shaft. This is the rack that walks back and forth. And then zoomed out, the rack would be right here. And your inner tie rod is actually threaded onto the rack body. So this is all cut apart. So you can see this is the rack. Literally the thing we thread the inner tie rod into, if you were to pull it out all the way, you'd see these teeth inside. So therefore, the rack. And then we have to find a way to link the inner tie rod to an outer tie rod or a tie rod end that gives us adjustability. And this is an old school one. We used to use these adjuster sleeves. And we covered that a little in alignment. Those were kind of a pain, but that was one way. We've gone even more simple than this. Now we're just threading that outer tie rod right onto the inner tie rod. And we're done. So here's, for example, what I was just saying. Your rack is inside. The inner tie rod attaches to the rack, and the inner tie rod has a tie rod end threaded right onto it, as you can see. There's all the players. Now, what's the purpose of the boots or the bellows? Those, very simply, protect the rack, the actual rack gear, and the seal from getting a bunch of debris and junk. So look at it kind of like this. I could show you right here. So if this is your rack gear, and this is the body of the rack assembly. If there's power steering fluid inside, the power steering fluid is going to leak out right here. So we drive a seal in right here, and the seal is going to fit very tightly to the rack gear. And as it moves in and out, not to be confused with double double, but as it moves in and out, we could have fluid that could seep out, but that's why we have a seal there. The thing is, if that rack gear were to come out and then let's say get dinged up by a bunch of road debris, and now it's got little pits and dents and stuff, you're gonna pull that rack back into the seal, and you know what's gonna do to the rubber? It's gonna rip it. So we have to protect that with boots. We do that with other things. The shock, right? If you look at your shock absorbers and your struts, the purpose of that boot is to protect the shaft and the seal, but especially the shaft, because if we ding the shaft up and we send it back through the rubber seals, you know, like that. Same with this. That's the purpose of the boots or the bellows. The bellows shouldn't hold fluid. They're not made to hold fluid. If there's fluid in there, the seal's already bad. And so we'll replace the seal, right? But not really. Like I gave you a little bit of a sneak preview in class last week. Those seals can be replaced, but there's typically a lot of special service tools to get one of these apart, and that's not something your typical technician does. In 12 years, I have had one student who knew how to do that, and I've never done it. And so he totally tripped me out. I was like, "You've done rack seals?" Yeah, we do those all the time. Where the heck do you work? Oh, we work at such and such remanufacturing. It's a facility that rebuilds rack and pinions. So it made total sense when I found out where he worked. The rack manufacturers do the seals, they do the remans. I don't know of any other shop that rebuilds those. So sorry to let you know. All right. Now, the way that those inner tie rods attach, we could do a lot of things. This is kind of a cool one. They call it the center takeoff. We'd actually have inner tie rods that would literally bolt up to a center part of the rack. That's pretty old school. I had seen a few of them. Most of the time, the rack is going to come in here, or the inner tie rod is going to come in and connect to the rack. We can sometimes use a roll pin. So this is a style where the tie rod end comes in, and we actually pound a roll pin in. This is another one where the tie rod comes in, and we actually use a set screw. Or they have swage sockets, which are like swedging is where you use like a tool and you clamp it and it deforms the metal, and now it's in there. So it could be quite a few different types. The most common one that we see is where it's threaded on and they use some sort of a claw washer, and those are the ones we can replace. So we can do inner tie rods, but generally speaking, and we could do boots as well. If you pull the boot off, you can replace the boot, but you got to pull the tie rod end off to get to the boot. And so it kind of depends on why you'd want to sell a boot, because you're going to have to pull a tie rod, put the boot on, put the tie rod end back on, and then also do the alignment. So that's your labor cost is high here in the US because we speak American, so it costs a lot of money. So if you're selling 2 or 3 hours worth of labor at $150 an hour, I don't know if replacing a boot makes sense, right? Because if that rack goes bad in another year, they just invested $500 to get a new boot. I don't know. See what I mean? So a lot of times we won't do a boot, but you could. You can do an inner tie rod. That's as far as we go. Cool. And so now what about if it's a parallelogram? So again, that's more important for large vehicle where we're looking for more ride comfort, not sporty handling, more complicated. And what I mean by that is there's a lot more components. That's it. It's not that it's harder to diagnose. There's just a lot more stuff going on. Pitman arm, idle arm, center link, tie rod end, adjustment sleeve. And there's going to be 2 tie rod ends, 2 inner tie rods, 2 adjustment sleeves. There's a lot of parts in there. Right. And then here's what you can look at it like from the front. So each one of these kind of little circles This is all a connection. So the tie rod end has the ball and socket. The pitman arm has the sleeve. The pitman arm has the ball and socket. A lot of times the center link may have one or two. The idler arm is going to have a ball and socket and a sleeve. So all this stuff's kind of loosey. And if you look at it too, proportionally, it just looks kind of weak to me. Like you got these big tires and you got these tiny little parts. So this is something that, if you want to go heavy duty off roading and you start bouncing off of rocks and stuff, you're gonna bend this stuff up. It's gonna get bent. Not to say that it won't mess a rack up, but this is really common for people to damage if they're doing some off roading. Even let's say you're not even off roading, you're mall crawling. You cruise to the mall, you go to park at Nordstrom's. Why you're parking at Nordstrom's, I don't really know. I wouldn't know anything about that, clearly. But you go to park at Nordstrom and you just hit the curb, right? You try to whip it in there, and then your tire hits the curb. You can see how your 4,000-pound vehicle could hit a curb and definitely bend some of these linkages. And now you need an alignment. And we might be able to do the alignment, but if your linkage is bent to the point where we can't compensate for that bend with the existing adjustments, now we're replacing bent parts. And so a thing to consider with all of these linkages is, especially on the parallelogram, there's parts that can be bent. And if they're bent, it may need to be replaced depending on how bent it is, right? So a little tricky. And then this just kind of describes how it works. And I sort of already described it, but one of the key things is a steering damper. So if it's on a heavy truck, like for example, this is a heavy truck right here. This would be a 4-wheel drive with a steering box. So that's a bigger vehicle. When you hit a little bump, your wheel is going to go left to right. That left to right is going to be transferred into a lot of these linkages, including your steering gear, which goes to your steering wheel through the steering shaft. So you hit a bump, that tends to cause this side to side motion. That can begin to oscillate, right? So picture for a moment, you hit a up and down, you hit a basically like a speed bump, right? A speed bump on the old Buick might have the Buick start to go up and down, right? Up and down. We dampen the up and down oscillations with shock absorbers or struts. What dampens the side to side? You're thinking, well, I don't know. Well, on most cars, nothing. But if it's a bigger truck and we already know they have bigger tires and stuff, so if it has a bigger tire, that's going to generate more of a reaction force when it's getting some side to side movement. We can actually dampen that using a steering dampener. So a steering dampener is mainly going to be something you see on heavy duty or something with big tires. So if you see a steering dampener on a Jeep that's from the factory, it's probably because they knew that there was going to be 33-inch tires from the factory. That's Rubicon tire size, 33s, right? If you think about that side to side movement, let's say you hit a bump and all of a sudden there's side to side movement, it can amplify. So this side to side movement makes an actually bigger side to side movement, which makes a bigger side to side movement. And that's made worse by looseness in the joints, but it also just has to do with frequency. So if you're traveling the right speed and you hit the right bump, all of a sudden that side to side movement gets stronger and stronger and stronger. And that's how you end up with this thing they call the death wobble. So the death wobble shouldn't happen because all of our steering linkages are good condition, but also, let's just say if it's factory, they've done all the math for that. I mean, the tire shouldn't be that big. Then you get somebody and they put bigger tires on the Jeep, and now all of a sudden that same bump isn't moving a 265, 65, 17. It's moving a much larger 285 or a 305 75, 16. That's a bigger mass that can tend to do these death wobbles. So one of the best things you could do is do a steering dampener. But that's an aftermarket add-on. What if it's a factory vehicle? Let's say it's this Ford F-350. From the factory, it's got a steering dampener, but just like what happens with our shock absorbers, they can leak and fail, and then we don't get the dampening anymore, right? It tends to keep going, keep bumping down the road after the bump. Well, it would do the same thing. If you've got a steering dampener that's leaking and defective, you may experience a death wobble. And so let's say you on the ASE you get a question or a customer rolls in the shop and they say, yeah, once in a while I hit a bump, I got a death wobble. First thing I'm looking for, front end inspection. Is it loose? Next thing, boom, flashlight. I'm looking at that steering dampener. Is it show signs of leaking? Does it look like it's old? So if I see signs of leaking, it's getting a steering dampener right away, for sure. So that's one of the reasons they show it. Now in this design, it's a little strange. They can vary. I actually did an alignment on a Wrangler and I videoed it just for you so you can understand if you ever have to do one of these alignments, it's very different. It has a tie rod end here, but it has more of an adjustment that'll be like this is the tie rod end, and there'll be one adjustment right here. And then there's the drag link that a lot of times will have an adjustment. And so it's kind of a weird setup. Like the tie rod itself controls your toe in or toe out, but the drag link controls whether your steering wheel is centered or not. So there's two very different adjustments. You don't just have a set of tie rod ends. I'm very, very, very familiar with tie rod ends. So when I got the Jeep in, and I kind of understood this, and I understood it enough where, using the machine, I could figure out what to adjust in what order. Then I realized we don't see that every day. And there's nothing stopping the ASE from asking you questions about a Jeep, right? So, or something with a solid front axle like this. So I put it on there for you. So that's a little benefit you get. But this is yet another type of steering linkage, and I wouldn't even really call it a parallelogram as much as the other ones, because I don't really see the parallel relationship. I would just call this a steering box style with a solid front axle. Right. And then if we go even a little bit more, you can see some of the things we're worried about. Excess play in the links and joints may lead to abnormal and irregular tire wear. Why? Well, think about it. Let's say your toe is dead ahead, 0-0, but you got a loose tie rod. Tie rod end's loose. This tire is doing this. This tire's in here. This tire's out here. It's towed in. It's towed out. It's going to be inner edge wear, inner shoulder wear, outer shoulder wear. Looseness is going to absolutely cause the same tire wear as a bad alignment. You can't have a good alignment if you have loose parts, right? Shimmy and other NVH complaints. Let me break that down. What I was saying about the death wobble. If you have looseness, that looseness compounds your issue. So if things are fairly tight, it doesn't give a whole lot of room. It's almost like you'd never do this, but let's say you're going to punch somebody. You'd never do this. Of course you would. Of course. But if you want to punch somebody and you only have 1 inch, it's the 1 inch punch, you're probably not going to really make a lot of force because you only have a little bit of movement, right? But if you have, let's say, a foot, you're going to pick up a lot more speed. You can generate a lot more force. So you hit that bump and it knocks the tire to the left. If it's fairly tight, it's not gaining a lot of momentum. If you have a bunch of loose stuff, that thing's by the time the gap in, let's say, the tie rod end is taken up, that mass of that tire is gain some momentum, and boom, next thing you know, you've induced a whole lot more force into the steering system. So steering wheel shimmy is a vibration of the steering wheel. Most of the time that begins with a tire wheel balance issue. However, that's made worse with loose steering parts. Kind of makes sense. And then additionally, NVH, meaning noise, vibration, harshness. So you feel things, you hear things, it just can feel like it's a vibration or harshness. That can cause some issues. Also, we need to we need to explain wandering, binding, and pulling. These are terms you're going to see on repair orders. These are terms you're going to see on the ASE. Wandering. Picture someone in class when we're in lab and they're wandering. Where are they? Where are they? Well, they're not where they're supposed to be. They're over here. They're over here. They're over there. You, let's not even make it personal. You can make it about me. In class, like, where is that guy? He's wandering all over the place. So when a vehicle wanders, you're trying to drive it and it's wandering over here, and then it's wandering over here, and it's wandering over here. Remember that discussion about the old cars where you're doing this? That was a vehicle wandering. You steer a little this way, car goes too much that way, you steer a little this way, the car is just wandering all over the lane. Cool. Now binding, back up. What would cause wandering? I want you to think about that. What would cause wandering? A part that's too stiff, a rusty ball joint, maybe low power steering fluid, maybe looseness in a joint, maybe a bad alignment. The answer would be that's more a sign of looseness. If you've got that right front tire that's got a loose tie rod end and it's over here and then it's over here and it's over here, there's nothing holding it steady because there's looseness. Looseness in the joints absolutely cause wandering for sure. Now let's discuss binding. Binding is where it gets stuck. So if you're steering and it's smooth and then it's stuck, or like last week, a group had Andres and Mario had a Kia Sorento for binding. You'd turn the wheel and it was smooth, and it would kind of like catch, smooth and catch, smooth and catch. There were multiple points that were binding. So binding is more, it's not because something's loose. It's actually probably because something's too tight, but not because it needs to be adjusted. It might be a defect, right? So if we have, let's say we're back to that tie rod. If that tie rod, the boot was torn, the grease leaked out, and then a bunch of water and road debris got in, it may be rusted. So that may be binding. Now it's binding, it's sticking, it's stuck, it's seized up, but maybe not totally seized. It might be kind of seized, right? So like with brakes, if a caliper is not sliding properly, it's binding. That's a binding caliper. We could have binding parts in the steering system. Absolutely. Depending on where and how it binds, that would mean different things. So like if it binds once every revolution of the steering wheel, we may be more thinking like the pinion. But if it binds, if you turn all the way to the right and then on the way back it binds once and you've had to turn the steering wheel 4 times, but it only bound once in those 4 turns, that doesn't sound like the pinion, because remember the pinion's attached to the steering wheel. So if it had a problem on the pinion, it would hit every time. Let's say it was at 12 o'clock, bind up, 12 o'clock, bind up, 12 o'clock, bind up, 12 o'clock, bind up. Cool. Whereas if you steer all the way over here and then you're turning and it's good, and then it binds at 6 and then it's good and then it's good, you've gone around the circle 4 times and it only bound 1 time. That's not going to be the pinion, because the pinion would bind every time. So that would actually be more like the rack. So actually, I'm going to tell you what, we're going to jump right back to this picture here. If it was a tooth right here on the pinion, that would hit every time at the same time in the circle. 12 o'clock, 12 o'clock, 12 o'clock, 12 o'clock. Cool. What if it was just one gear right here? That would only hit as you turn far to the right or whichever direction. It only hit once through the whole lock to lock cycle. Right? They get asked something like that. And then as we get a little bit further in, we did talk quite a bit about the linkage, but we have not really talked about the steering shaft. If a steering shaft is binding, that can bind in multiple points, 12, 6, or 12, 3, 6, and 9, because the joint has to flex as you turn it, right? So it could help you to diagnose the car in several ways. And also just think about it. There's quite a few ASE questions that can come about that. Kind of makes sense. And so we'll probably even come back to that one more time. So that's wandering, that's binding, and then pulling. You guys know pulling is literally if it's the steering wheel is generating a pull force. Not if you let the steering wheel go, which way does it tend to drift? It's more like you're holding the steering wheel and it's constantly tugging on your hand one direction or the other. Those are the three. Other problems that could be linkage related: hard steering, poor steering wheel return to center. So this one, hard steering. I'm going to tell you a fairly quick story about one of those that absolutely slaughtered me, made me rethink my career decision, to be honest with you. I had it's old, okay, but some of you guys know about these cars. An Astro van. Okay, Astro van came in, totally hammered, tons of miles, piece of junk, like every Astro van that's ever existed. And this was back when they were kind of new, but it was just hammered. And their concern was, and I still remember almost exactly what the repair order said. Steering, steering feels stiff. Simple. It's like steering feels stiff. Cool. Went out, jumped in it. I've driven a ton of Astro vans. It was one of these ones where you'd start it, things were okay, but like if you were at idle and you went to turn into the steering into the parking spot, it was kind of like, oh, okay, this takes a little bit extra effort. Like you got to almost two hand it. But what's interesting is if you were rolling a little bit, it would steer okay. Makes sense. So it was kind of like the steering was just a little bit weak. And also, if I revved it up a little bit, it would actually improve it. And that was really common for bad power steering pumps. The power steering pump wasn't totally shot. It was just starting to make a little bit of low pressure where if you put a high demand on it, like you're stopped, it just was a little stiff, right? It was a little hard. And if you revved it up, the pump would turn faster and it would help build a little more pressure, right? So I'm like, no big deal. It's a pump. Sell a pump. Put the pump on. 2 days later, I see an Astro van come in the back of the tow truck, drop it off, and they said, "Hey, it still does it." I was kind of like, "What do you mean it still does it?" It was stiff, and then I replaced the pump, and it was good, and it still feels good. So I jump up in it, and I'm like, "This is fine. It feels good now." And so I went to the service advisor, and I said, "Hey, we need to talk with this customer. I'm a little confused. You know, it was kind of stiff before, and now it feels good." And he said, "No, no, no, that's not what he said. He said intermittently it won't turn at all. It'll bind up in the middle of the intersection. And he won't be able to move it." And I was kind of like, that's not what the repair order said. You see where I'm going, right? That is not what the repair order said. Well, that's what he said. And I was just kind of like, are you serious? And I won't use names, but I still remember the service advisor. And so at that point, I realized that is not a power steering pump issue. A power steering pump will give you not enough assist. If the steering locks up solid where you can't turn it at all, that's drastically different. Totally different. So think about it. We talked about the linkage, a hard steering. This one is being like I had to end up driving it all over the place, and then I hit a bump, and all of a sudden, boom, it locked up. I was like, oh, this is kind of scary. Hard as you pulled, the steering wheel wouldn't move. Engine on, engine off, pump running, pump not running, didn't matter. Boom, totally locked up. So I thought about the steering linkage and I thought, the thing is, I don't know for sure if it's in the steering or in the suspension. Because if you think about it, when you turn the steering, you're actually moving the suspension, right? So I'm moving the knuckle on the ball joint. So I thought about it. Is it possible that a ball joint is seizing up solid and then it won't turn? You guys follow my logic there? So if a ball joint's locked up solid, I wouldn't be able to turn it. So because I had already misdiagnosed this one, which I kind of defend myself, it's like that repair was written up so bad, I don't even want to take the loss for that. I want to blame somebody. And maybe I'm right, but the problem is it's still my problem. Service advisors don't have a lot of skin in the game, right? It's my comeback. I'm not getting paid. I can't afford to misdiagnose it twice. So I think, I I I somehow get the thing into the bay with the steering locked up, and I literally decide, how am I going to know if it's the steering or the suspension? So I actually go ahead and I pop the tie rod end off of the knuckle. If a ball joint's locked up, what would happen if I pop the tie rod end off the knuckle? What happens when I try to turn it? You can answer this one. It's a ball joint. Would I be able to turn the actual wheel and tire? What do you guys think? Don't be shy. Don't make me check the chat. I see it. The chat's blowing up. Yeah, if it was a ball joint, though, if it was a ball joint, I wouldn't be able to move the knuckle because remember, the knuckle pivots on the upper and lower ball joints. So I popped the tie rod end off and I moved the not the steering wheel, I grabbed the tire and I moved the tire and it was like, oh, the tire's moving smooth. So that tells me the upper and lower ball joints are fine. But then I had to do the same on the other side. So I disconnect the tie rods and I move it and the tire. You know what? I didn't do it on the lift. It messed up out in the parking lot. I pulled the floor jack out. I lifted it and I popped the tire rod off and I was able to move the tire. So the wheel and tire would move. So the ball joints weren't messed up on both sides. So then what I did was I was thinking about it. You grab the steering wheel, you turn the steering wheel, it moves a shaft inside the column, which moves the steering shaft. That's one of the things we're going to next. And then that moves the steering gearbox. So I thought, well, if I unbolt the shaft from the gearbox and I can move the steering wheel, I know it's not in the column or the shaft. So I unbolted it from the steering gearbox and I was able to move the steering wheel. Now, if you followed me, what's that leave? What do you think is wrong? Steering wheel moves with it disconnected from the box. Wheel and tire and knuckles move when it's disconnected from the tie rod ends. What's left?
The rack.
Yeah, in this case, it was a steering box, but it was an internal rack and pinion type of steering box failure. I'm pretty sure, to be honest, I've got a lot more experience now, but that was my first year of being a full fledged line tech. So, like, I made little problems into big problems sometimes. I'm coming clean and I'm telling you, like, I was overwhelmed. I knew some stuff. I had passed some ASEs, but like in reality, when you get the job dispatched to you and there's nobody there to help you and oversee you and stuff, it's like, hey, the car's here, it's binding. I'm sort of like, I mean, I think I got a lot of ambition, but didn't have a lot of experience. When I retell the story now, I realize, think about this. It locks up solid and you can't move it. Ball joints don't do that. The only thing that's likely that would have happened is if we look at back at one of these rack pictures real quick. What if one of these teeth broke off and was bouncing around in there? Because remember what I told you, I hit a bump and then I could not move it. That's like a dead giveaway that it was inside the steering gear, right? So now that I look at it, first off, what I would have done now, I know the system better, but also I think I just gained some life experience. If they would have given that to me and the steering wheel were stiff and I were to feel it and be like, it's a little stiff, I'd go back to the service advisor and say, hey, what's this customer really concerned about? Because it's a 200 something thousand mile Astro van. It's a little tough to steer in the parking lot. I highly doubt they brought this piece of crap here because it's a little hard to steer in the parking spot. What's the real story? And they'd be like, oh, it locks up when they're going through intersections and they can't move the car and it's a danger. I'd say, okay, that makes sense. Let's, and I would try to do it nicely and just say, dude, let's work on your write ups. I could have misdiagnosed this car because your write up was trash. If it locks up in the intersection, write that down. You didn't tell me any of that stuff, right? So I'd have tried to remediate the service advisor's write up ability. And then secondly, once he did write that up, I would have went out to the car, I would have drove it, it would have felt fine. And I either A, would have kept driving until I duplicated it, or B, I probably would have reached out and had the service advisor tell the customer, hey, we're not really worried about the pump. We're not really worried about ball joints. If it's locked up solid, more than likely you got a broken tooth inside the rack and pinion or the steering box. And I've actually seen it once since then too. So I retell the story and I realize it would be easy to fall for you to fall down the same path that I fell down. And I don't want you to. So I want you to understand it, but also that doesn't mean just knowing your technical ability well. If something doesn't make sense, you might do a little bit more poking around before you make it super uh, technical. I made that problem a bigger problem than I needed to. Right. So back to those things. We're talking about the conditions. Okay, that one was a hard steering for me in two ways. First, it was a little stiff, like the power steering pump wasn't given enough assist. That's a hard steering. The other one was the steering will lock up solid. That's a hard steering, but I wouldn't call it a hard steering, but they're both related. And then poor steering wheel return, that's what we were talking about with the memory steer. So that would be, again, let's say, and I don't know that I've actually experienced this one, but I've definitely seen on the ASE, you're rolling down the boulevard or something, and you turn to the left, you let go of the wheel, it goes left until you literally center it back out. That would be poor return to center. That could actually be a ball joint that's sticking or a strut that's sticking. And if you wanted to know for sure, you could probably most likely tell just by looking. But if you look at the ball joints and they look kind of plump and sealed, it's probably not a ball joint. If you feel the ball joint, it doesn't feel loose. If they don't make noise, it's probably not a ball joint. Then I would probably put my attention up to the top of the strut and I may spray some oil down in the strut mount, try to get oil in that bearing. If we had to go a step further, like again, Andres and Mario, it might have been 2 weeks ago, we actually removed the strut out of that car that had a notchy binding feeling, and they greased up that bearing and put it all back together to see if that was resolving some of the binding and the return to center. So there's some things we could do to really narrow those down, but these are things you could see. And then a lot of times the visual is going to check that. Sometimes we'll have to go further. Now here's another one. This is the dry park check. The dry park check is basically you pull it into the bay. You can have the car running or not running. It's not super important, but it's more helpful if you have it off, because when you have it off, you don't get power assist. So it's a little, you can feel it a little bit more. The pump's not helping you as much. So you'll drive it in, put it in park, shut the engine off, and you'll move the steering wheel, right? And all the steering wheels will have a little movement. But if it has extra movement, that would fail the dry park check. If it fails the dry park check, it could be inner and outer tie rods, steering gear mounts, steering shaft joints, wheel bearing, steering gear. Something is loose if it's got excessive movement on the dry park check. All right. And so, and Madi, I saw your question in the chat, so I will answer that. Back here when I was talking about the hard steering, ball joints that are bad could cause it to be a little stiff. I don't see a ball joint possibly being bad enough where you can't even move the steering wheel with all your force, with all the power steering force and everything. I don't see a ball joint ever being seized like that. I don't think it'll ever happen. I could see it if a literal gear is broken off, gear to gear. The gears are supposed to mesh and a piece is wedged in there. That actually made some sense. Right. And then another one, if you fail a dry park check, you need to know what's loose. How do you know what's loose? Bring the car in the lift, put the car up in the air. You may have to remove the tire wheel, you may not, but then you're going to have to find the looseness. So again, looseness is this. So the best way I can explain it, if you were to basically put a dial indicator on this thumb and then move it, you could actually measure how much movement there is on my thumb with the dial indicator. That would tell you how much play there is between the parts. You're essentially going to be looking for parts that move and don't move. So if we were to move the wheel and you were to notice the outer tie rod is moving with the wheel and the inner tie rod is moving with the wheel, but the rack and pinion is still, that would mean there's play between the rack and pinion and the inner tie rod. And so therefore it's actually the inner tie rod ball and socket joint, right? So you're looking at the difference moving and not moving. We'll make a video on some more of the inspections. We've already done some of that, but we'll find a good one, right? And now a little bit more on steering columns. So steering columns is part of the linkage, but it's sort of its own linkage. So the steering column is going to take the effort from the steering wheel, transfer it to the steering column or shaft, and it's ultimately go to a steering gear. Steering box, steering rack, doesn't really matter. The steering column is the same. So back in the day, it used to be a straight shaft running inside a hollow tube. Now, here'd be the problem. You got in an accident, your frame was damaged, it bent your suspension, it shoved your steering box toward you, right? Because your steering box in the front of you. So if you get in an accident and the steering box is shoved toward you, you have a nice steering shaft that pretty much is ready to impale you. Okay, so that's kind of the point. The old school steering columns weren't. It wasn't a really good idea when you got in an accident to have something that was a solidly mounted shaft pointed straight towards your heart. So they've done away with that. Now they're collapsible. So if you get in an accident, really the actual steering shaft can collapse. The steering column can collapse. There's quite a bit of things to make it so you don't get impaled. Essentially, that's kind of where we've gone. And then if you look, this is inside of a steering shaft. So before a shock, or and this could also be in the column too. Before a shock, these are held together with some sort of a resin. It can vary, and sometimes they also have bolts that bolt the column up, but they're set in clips with enough force they'll actually break the clips, and those are held in with kind of plastic, and the shaft is held in with plastic. That is collapsible because it'll get the shaft will get collapsed on itself. So the impact will actually break that resin and shorten it. It won't shove it towards you. So all this stuff, it's not super critical for us on a day to day, but just know if something's in an accident or collision, more than likely a lot of this stuff could be damaged if it's bad enough. We could damage the shaft, we could damage the column. Cool. And sometimes they have inspection procedures that can be a little tricky. So if you look back here, these were further apart after the shock. They're closer together. If you looked at these clips, they were attached, and after the accident, they detach. So it can bend the bracket, but the column won't move. Kind of a good idea. And then we get a little bit more into steering columns. So this is again showing the collapsible uh, column. So this one, for example, this is going to go down here to the rack or to the steering box. This right here we call the intermediate shaft. There's going to be a universal joint, a connection. A lot of times right here, this can telescope, meaning it can get longer and shorter. It can telescope like this. And then there's an upper connection that's going to go right to the base of the column. And the column has the shaft going up through the center. So this is your steering shaft, your intermediate steering shaft right there. This has a universal joint, and this has a universal joint. And those could go bad. If it was a universal joint that was bad, you'd likely get either a looseness, and we've seen the looseness, click, 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 click. Or you could get binding, and the binding would likely be at 12 and 6 or 12, 3, 6, and 9. Every 12, 3, 6, and 9. That would be more of an indication of the universal joint. You want to know for sure, you could actually unbolt it and flex it around and see how it feels. A couple notes on this. If you go to do a rack, which a couple people have done, but everybody's going to be working on that this week. If you go do a rack, you need to disconnect the steering shaft. On some of the domestics, the steering shaft only bolts on in one place. So you can just disconnect it. But on a lot of the Japanese, and Toyota included, this shaft is female splined and the steering gear is going to be male splined. And those splines can go on in any different way. So when you go to pull this off, you need to mark the shaft, the intermediate shaft, and you need to mark the pinion shaft on the rack. And then you can pull the bolt out. And you can't just loosen the bolt, you have to pull the bolt out. There's a safety mechanism like a detent. So you can't just loosen it. To take it out, you have to pry it off. When you go to put it back on, you have to have it put back in the same spot. All right, so and if you get it off a spline, your steering wheel's off center. And if you get it off 10 splines, your steering wheel's way off center. So the rookie mistake is, if you think about the alignment, you set the alignment let's say the alignment was good when the car came in. If you pull the shaft and you put the shaft on and now it's off, it doesn't need an alignment. It needs the shaft installed in the right spot. So what you'd really need to do is essentially you need to get the wheel straight ahead. You'd need to pull the shaft off, get the steering wheel straight ahead, and then put the shaft back on. But that's a little easier said than done. Let's say you're one tooth off just a little bit. You could actually fix that with an alignment. The thing is, though, on one side, you're going to be unthreading the tie rod, and on the other side, you're going to be threading the tie rod in. There's only so much adjustment. So if you're one tooth off, you probably can get away with it. If you're 5 teeth off, you're going to end up unthreading one, maybe too far, or maybe so far where there's like this much thread showing, and then on the other side, you're going to bury the tie rod in, so there's like this much thread showing. If I get a car that you worked on and I see this much threads over here and this much threads over here, I'm gonna call you out. It just means you really don't know what you're doing. See what I mean? So it's important that we get this shaft on the right spot. If you get a car that's messed up like that, the way to fix it really nicely, get it up on the alignment rack, put it up in the air, get it so you could actually do the compensation, looking at your toe, set your toe so that you don't have any toe in or any toe out, but you have the same amount of threads showing. So, right, you're just going to rough it, boom. You got about this much threads and about this much threads. The alignment machine will tell you when your wheels are dead straight, get them dead straight, then jump in and look at your steering wheel. And if it's off like this, you know you have to disconnect it, turn that shaft a half a turn, pop it back on. Don't even torque it all the way. Just go back up and check it. And if your steering wheel is still a little off, pop it back off and move it. Get it to where the wheels of the car are straight according to the alignment machine, and your steering wheel is straight, and you have about the same amount of threads showing. And that's what we call zeroing the rack. Then at that point, you can tighten the steering shaft and you can fine tune the toe, and that'll be a good job. But there is something, one tooth to fix, one tooth off. Yes, I agree. Now, about the seatbelt, there's another thing that can happen here. So if you look at this steering shaft goes to the rack or to the box. The rack or a steering box has a way to stop rotation. So if you turn all the way to the right, you feel a boom, right? It clunks. That's the steering stop. Turn all the way to the left, boom, it clunks. Cool. You bring it to the center and you disconnect the shaft, and then let's say you do a new rack and pinion or whatever, there's nothing stopping your steering wheel on the car from spinning. Nothing. So if you get up there and you accidentally turn the steering wheel a full 360 to the left, it's no longer centered. Now that's a problem, as we're going to discuss in a moment, with the clock spring or the steering. We may call it's SIR coil, so supplemental inflatable restraint coil, or they could call it a few different things. Let's call it the clock spring. Let's call it. Messing with me. So if it's a clock spring that has a spool of wire, right? That spool of wire is good for, let's say, 3 turns to the right, and then center it back to 3, and then 3 turns to the left. But that's as far as it can go. They only have so much wire in there. If you disconnect that steering shaft from the rack, you accidentally have the steering wheel turn 1 to the left, and then you hook it back up. Now, the very first time you go to turn the steering wheel all the way to the left, it goes 2.5 turns. You run out of wire, you snap the wire, pow, steering wheel, the SIR coil, clock spring now has an open circuit inside. Broke it. You're going to get the airbag light on. You're going to have no horn, and any of your steering wheel mounted buttons are not going to work. That makes sense why? Right? So what we'd need to do is, when you're about to disconnect the steering shaft, I'd run the seatbelt through one of the spokes of the steering wheel and then buckle the seatbelt. That way it's not that it can't move a little. It's okay to move it a little. It can't end up a whole turn off. Because if you jump in the car and you turn 2.5 turns to the right, center it, turn 2.5 turns to the left, they make a little wiggle room where you could potentially turn 3 turns, but you can't turn 4 turns to the right. You're going to break the wire because it's going to be totally unraveled and tight, and then it's going to go pink. Cool. So that's why we seatbelt it. Now, if that ever happens to you, and I could show you in person, and this has happened quite a few times, but let's say that you didn't put the steering wheel and you thought it might be off. Okay, I could teach you kung fu. You can get in the car, disconnect the steering shaft, and then get in the car. So that means now you can turn the wheel as much as you want, right? There's nothing stopping you, which means you're at risk of snapping the clock spring wire. Get in the car, learn kung fu. Silence. Close your eyes. Normally, when someone tells me to close my eyes, I don't do it. I don't trust them. But in this case, you have to. Close your eyes. And you're going to move the steering wheel gently, gently fingertips, gently. And just like if you're really in tune with your kung fu, you'll actually feel where the wire gets tight. You go like, okay, that's it. You'll turn the steering wheel, you go like, tight, okay. Then open your eyes, make a note of where that steering wheel's at, and then you're going to count your turns, right? 1, 2, 3, 4, and let's say it's like right at the 5th, and you're gently, gently, gently with your eyes closed again, and you feel the wire tug, boom, and that's 5. And you're like, all right where it's at. If it was 5 turns from all the way to the left, all the way to the right, I should bring it back 2.5, and boom, now it's centered. So you can come back from that, but you got to be really like, if you try to turn that wheel too fast, you'll snap that clock spring and you'll be like, oh, I don't know what happened. I'm letting you know, eyes closed, very silent, very patient, feeling, just feeling. Center it, boom. Cool. You can do this. Now, if I asked you a question, after a vehicle had a rack and pinion replaced, the horn doesn't work, what happened?
They broke the clock spring.
That's going to be the answer on the ASE every time. If it's anything to do with the steering shaft, something to do with unbolting the steering column from the steering gear, whether it's a box or a rack, they're checking to see, do you understand it could have been turned too far? That could be a airbag light on, a horn and up, or the radio buttons and up, because they all go through the clock spring. Cool. You're going to see that. I'll bet you $1. All right, so there's quite a few parts. I don't go crazy on the parts, but just note, we could be talking about doing a wiper switch. If you need to do a wiper switch, you're basically doing steering column work and get a little tricky. If you're going to be doing any of this type of work, or let's say an airbag, there's a chance you might actually have to disable the airbag system. So there's tons of parts on there, including ignition switch, all sorts of stuff, right? And then there's a little zoomed in one. So like for this one, this actually has they can have several different types of motors. Sometimes the motors for tilt and telescoping, but in this case, this is electronic power steering, where the motor is on the column, which was really popular, and it's getting less and less popular. But steering column service could actually be for an electronic power steering system motor type of thing. All right, so lots of parts there. Pretty good for you. Again, even if you're trying to do some of this type of work. Now, what about this? This is before the clock spring, so this doesn't go through the clock spring. You might actually have to remove the clock spring to change it in some cases, most of the time not. But these are on the steering wheel, which means you're turning the steering wheel. They can't be hardwired through the column. It would have to go through the clock spring because it's mounted on the steering wheel. So all of these would go through the clock spring. Kind of see the difference. And by the way, ASE may call it the clock spring. They may call it the ribbon cable. I've heard it called the ribbon cable. Or it could be the SIR coil. SIR meaning supplemental inflatable restraint coil. 3 names, same part. All the same. All right. And then some of the tilt telescoping mechanisms, they can be kind of complicated. I wouldn't put a whole lot of emphasis on this other than just understanding, if you have an issue where the steering wheel won't tilt, that's up and down, or telescope that's like closer or further from you, you may be under here actually testing some of these motors, seeing if they're getting voltage and ground or not, etc. Kind of similar. And sometimes there's control modules, in which case you'll be plugging in the DLC3, you'll be checking for DTCs, you can look at data, you can do active tests. All right, so it's nothing really different than what you already know. It's just specifically applied to the column. And if you understand that, that's really probably pretty adequate. Okay. And even this one, you can see this is a telescoping motor, and the module can be right on the column itself. We can still communicate with this though through CAN network. So you'd use the TechStream or GTS Plus or something. And the way we diagnose this is kind of similar to ABS, which is going to be similar to electronic power steering and every other system. All right, and then this got in. Lexus is a little bit special because they use Hall effect sensors. It's basically like a really high-end fancy tilt telescope. So if you look at something like this, your telescoping sensor is telling this ECU the location, and then if the customer's request is to have it in a different position, it's going to reference the position sensor, and then it's going to actually give 12 volts to this side and ground to this side, and that should move the motor, in which case the sensor should respond until it's in the desired position. Or let's say they want to go the other way, it can actually give 12 volts to the opposite side and ground to the opposite side. That'll move it the other direction, and this sensor should be able to basically show the change, show the movement, show the position. My brief, very, very simple explanation for this, I'm just going to annotate it. On these sensors, we're typically looking here for 5 volts. Right here, we're looking for ground, as you can see, right? You can see it goes to ground. This middle one should be between about a half and about 4.5. So if let's say it's all the way down, maybe that's where it's a half a volt. If it's all the way up, that's where it's a 4.5. If you're dead center, what do you think that's going to be? I'll just read this screen. That'd be 2.5, right? So this middle wire is the one that actually indicates the position. And so when we're doing some of our ASE prep, and we've done a little bit on these before, just remember these 3 wires have a 5-volt reference, a ground, and that middle wire is the one that sweeps depending on the position. This is a simple potentiometer. Half a volt on one end, 4.5 on the other end. If this wire right here is showing a 0 volts, that is going to set a code. How did it get 0 volts? Well, either A, the ECU is not giving 5, B, the 5-volt circuit is open, and so therefore it cannot get anything other than 0, or it could even be this, so it could be the 5-volt wire, or it could even be the sensor, the signal wire, right? If this was reading 5 volts all the time, it would probably be because either the ECM's not giving ground, there's an open in the ground circuit, right? So that's basically how we troubleshoot those. And we'll spend a little bit more time on position sensors, but in the case that you're looking at this is the type of a diagram you may see if you encounter a problem with this. Diagnosing the sensor is not super tough. What I would do, we'll go to annotate. I'm going to clear everything, clear all the drawings. What I would do to be really simple, I would take a jumper and I would go, let's say I could access this. I would put a jumper here on the 5 volts. I'd hook the tech stream up and I'd look at the sensor and I would jumper 5 volts to the signal. And what should the signal read on tech stream if it reads in voltage? I'd jumper that. How many volts are on that wire right now? Who knows? I'm also watching the chat. I jumper 5 volts to this wire. How many volts does the wire have now? It better be 5 volts. I should be able to, exactly. I should be able to go on the tech stream and I should see 5 volts. Cool. If I see 5 volts on the tech stream, that tells me my 5 volt reference is good. It tells me this wire is good. It tells me it's making it all the way back here. And actually, I wouldn't jumper it here. I really should have jumpered it over here. Right. So that tells me a lot about the system. Now, if I were to go through and disconnect the jumper and I were to jump ground to here, what should it read? Zero volts, exactly. But if it didn't read 0 volts, I would know that I should jump it over here. If I jumped it like this and it didn't read 0 volts, I would know that either something's wrong with the ground or something's wrong with this wire. There's something going on. That's when I would bust out my meter and I would say, okay, this terminal should have 5. This terminal should have ground, which I could actually do in one step. I could put the black lead on ground and the red lead on positive, and I should get 5. If I read 5 on my meter, both the 5 volts and the ground are good. Then on this middle, on the signal one, well, that voltage reading should vary depending on position, right? So real quick, boom, 5 volts, boom, ground, ready to go. Then on the signal, well, that one's a little bit tricky. It should measure somewhere, like I said, between a half a volt, 4.5. And as I move it, it should change, right? As I move it from down at half a volt, it should go 1 volt, 2 volts, 3 volts, 4 volts, 4.5 volts. That's how you troubleshoot it. Cool, simple. You get something like that, it's going to set a code. I will guarantee it because that's how DTC logic is written. Cool. Now let me go back to the pointer. I think this will work. All right. And then again, just to reiterate, if you're working on these columns and you're doing stuff like that troubleshooting, you may really want to consider disabling the airbag system. And that's going to be covered, but we'll cover it real quick. What are you going to do to disable the airbag system? Disconnect the negative terminal, wait a specified amount of time. Exactly. It's in the chat. Good answer. You could also, in some cases, remove the airbag fuse, but that's probably less of a good way. And the answer of follow TIS, that's probably actually the best answer. You could pretty much, that's basically the same as like if you're in church and you don't know what to say, you just say Jesus, you're probably correct. Like follow TIS is right. And it is true, but it doesn't really test if you know what I'm saying. So look up service information is good. Generally speaking, disconnect the battery, wait a specified amount of time. In some cases, it may be a little unique. And if you're really worried about it, disconnect the airbag, remove the airbag, set the airbag someplace else. You can't possibly accidentally deploy an airbag if it's out. So that's another thing to consider. And then here was a cool one of that clock spring shown, right? So if you're going after that clock spring because we accidentally broke the coil because we were doing a rack and we didn't seatbelt it, you're going through the airbag and you're going deeper into the column, and here's that coil. So you can see there's a handful of wires going in. On the other side, those same wires come out, and it's wound around a few times, probably about 6. So it's good to turn about 3 turns and 3 turns, but it can't handle 4. You run out of wire and snap them. I've not personally done that, but I've had several students do that, and I've seen it happen in the shop a bunch of times. Now this gets into a little bit more of the power steering gearbox. So I do want to show you a little bit, but full transparency, this is not the type of system you're going to be seeing every day. So don't prioritize this super high. But basically the worm gear is the type of a steering gearbox. This is a worm gear right here. So the worm gear is just a design. All right. And it's kind of interesting because if you turn the worm gear will actually move the sector gear, and the sector gear will basically rack back and forth. That's how we make the motion, how we make the steering motion. And then the ratio is a comparison of the angles of movement. So let's back it up. If you turn the worm gear one time, how many degrees of movement do you get on the sector? Well, that would be the gear ratio. So it all has to do with the sizes and the length. And the reason we cover that is because, like, let's say you're driving a tractor trailer. If you ever look at the driver, they go around a turn, you'll see them. They're like whipping that wheel. They're like hand over hand whipping it. We need a lot of big leverage there. So if you have a lot of leverage, that's going to make it easy to steer that steering wheel. It's kind of like a lever. You got a big old pry bar on it, a little pivot point. You can bring that pry bar up and down 3-4 feet just to get 1 inch of lift. That's how I'm able to move some big boulders and rocks, right? I can move some big old boulders and rocks, and I'm not that strong, but I've got massive leverage. It's the same for this. So the positive is it makes the steering really easy. The negative is you got to throw the steering wheel a million times. So that's fine in a truck. But if you're driving like a Civic, because you're in the Civic club, you don't want to be like, oh, let me turn around this turn. So a Honda Civic is going to have a very different gear ratio in the steering system than a tractor trailer. It all has to do with the ratio of the gears. Cool. So we get a little further in, and that's what this means by the gear ratio. Um, Essentially, that's probably explained even better than they have. Sometimes they do have roller and recirculating ball type. So this is again kind of getting into worm and sector. So there's the worm gear, and that moves the sector. And then if you think the sector is actually splined to the pitman arm shaft, and the pitman arm shaft actually accepts the pitman arm, which goes out to that center link and makes it move back and forth. Cool. So that's a visual. And overall, a lot of this is just going to be how the motion works. So if you can visualize it, it's going to be pretty good. So now we do have a roller style, which can make it easier to turn, and they've evolved a bit. So this is the Worman roller, just a different style, same type of technique, but as far as we know, the box, we don't really know what's in the box. Whatever's in the box is a mystery inside the box, but you will find that some work easier than others, and it may be because it's Worman roller. The recirculating ball was actually really common for a long time. And so a lot of it's similar, sort of what it's saying, but we've added literally ball bearings. And as we turn it, it rides on the ball bearings, and the ball bearings will actually move all over the place. And so back in the day, it was extremely, this was the ticket right here. The recirculating ball was the money. It was like, man, this is so nice. We got the recirculating ball style steering, right? And then we got the rack, and all this stuff kind of went away. But here's those recirculating ball. So the balls are rolling around on that worm shaft, and they literally get moved as they go. They'll literally roll into and out of this housing, and that's just moving the sector shaft. This is the first time we've introduced the pump in the reservoir, but we're coming back to those, okay? We're talking about, for now, we're talking about the steering gear and the linkages, not so much the power steering, really, but we will. All right, so there's your recirculating ball style. Here's what that looks like tied in, right? Steering shaft goes down from the column, right, to the steering gear box. Steering gear box is going to move with the worm gear to the sector gear, which attaches to the pitman arm shaft, which is attaches to the pitman arm, which is attached to the center link, guided by the idler arm, which moves the inner and outer tie rod, which ultimately moves the steering arm and knuckle, which moves the wheels. So that's your whole visual. And then, yes, we're going to add power steering pump, belts, hoses, fluids, everything soon. Cool. So we finally move on and we're to the rack and pinion. Rack and pinion will be a little more detailed on, okay, because that's what we're really using. But there's a little bit of the rack has also evolved some. So in older style fixed rack and fixed ratio rack and pinion, you always got the same amount of leverage. So like what I was saying with the truck, hand over hand. What's cool is we can actually have truck style steering ratio, but then Honda Civic style steering ratio at different points. And so a fixed would just be one in all positions. But we do have some other types. So the arrangement has a large degree of feedback and direct steering feel. Sporty car, you can feel the road better. You hit a pothole, you feel it more. But also like when you're going around a turn and you start to go too fast and you start to feel like light, it's kind of disconnected. You know that you're sliding. It's almost like you're on ice or snow. All right, let me translate this. It's almost like it just sprinkled for the first time in 9 months in California, and you go around a turn and it gets a little light. Yeah, because the other stuff wouldn't work so much for the people living behind the orange curtain. So it's gonna feel much more in tune. If you're starting to lose traction, you can feel it really good on a rack. Cool, it's better. And then we'll get a little bit further into the different ratios. Pretty good. So we definitely support those using some sort of bushing or mounting bushing or sometimes a clamp. A lot of times internal to the rack, if it's a manual rack, we literally have like grease packed in there. But if it's a power steering rack, we're going to run power steering fluid to lubricate it, right? So some of this is true. And then some of this is like, we don't do manual steering anymore. We used to. You could buy a manual steering Yaris back in the day, a Honda Civic too, but we really don't do that anymore. We haven't in quite a while, right? And so kind of this is self-explanatory. So here is your rack and pinion. There are bushings or bearings here. Those need to be lubricated. The rack has bushings. That needs to be lubricated. Again, on a modern one, this is going to be all bathed in power steering fluid. So it gets great lubrication, clean lubrication, and it's circulated. And we can actually put filters in power steering too. And then here's your knuckle. But this knuckle actually has a bolt-on steering arm. So this steering arm, that's the thing that gives us the toe out on turns. So it's kind of funny. If you steer this all the way in, this was a steering stop. So right here, this would actually hit here, this silver part, and we could put a little dab of grease on there. And sometimes you can actually even adjust these to stop the steering sooner or later. But generally, this is gone. We've now put the steering stops inside the rack. The rack will actually bottom out and bump the end. And that's when your steering wheel goes clunk. That's up against the lock. That's the turn. I got the steering up against the lock. Against the lock. Cool. You don't want to keep it there too long if it's hydraulic power steering, by the way. Ask me how I know. Actually, don't. I don't want to tell you. All right. Now, if you look, we've got kind of an interesting power steering rack here, and these teeth change depending on their position. And this steering rack has a variable gear ratio. So when you're pretty centered, it can steer one way. It's like when you're centered, you want fine-tuned movement, right? You don't want to turn it like a quarter of an inch and have the thing veer off the road. So when you're centered, it's pretty slow responding. But as you get to the end, it's going to start turning faster. So like when you go to make a U-turn, how cool would it be if you could just do a U-turn like this? Just be like, wham, and it does maximum turn. I mean, it'd be like a go-kart. It'd be cool. Well, this can't quite do that, but it gets a little closer to that. It's very fine in the middle, and towards the edges, it's a lot more. You get a lot more movement. Cool. So this is one of those designs. This is the variable gear ratio. They can do this in a lot of different ways. In this case, they're really using the longer center gear tooth. So it's all got to do with these teeth on the pinion. Again, we talked a lot about the gear ratio. This one happens to vary. So if you look at these teeth in the middle are nice and fine, and towards the outside, they get bigger and bigger and bigger. So this is going to have a fine tune, and this is going to increase that stroke where you get the more movement for the smaller steering wheel movement. And then what's really crazy, this was Lexus specifically. Lexus actually had a variable steering gear ratio that was adjustable depending on a few things. So this variable gear ratio steering actuator could give us fine steering or go-kart steering, but it would depend on the ECM, the skid control ECU, and the skid control ECU would look at vehicle speed and yaw rate. So rather than just being go-kart steering on like a hard turn or like when your steering wheel's moved a lot, it could change based on your speed and your directional intent. Meaning, if it felt on your yaw rate sensor, if it could tell that you were turning a lot, it could actually modify your ratio. So let's say you're going really fast. Do you want go-kart steering or do you want fine-tuned steering? I want fine-tuned steering. Well, the vehicle speed sensor sends a signal to skid control ECU. The skid control ECU communicates with the variable gear ratio steering ECU, and it gives you fine-tuned. It can literally change it. It's pretty trippy. So again, if you wanted to diagnose this, you could do some tech stream diagnosis and stuff. This is really not an ASE concept. It's cool to know how serious Toyota Lexus took this and some of the things they've done. And then again, here's your low speed. It'll give you more turning on the tires for the same steering wheel movement. Whereas like if you're at high speed, you'll move the steering wheel the same, but it'll only move the wheels just a little bit. That's the variable steering angle. I want to pause at this. I mentioned earlier, there are vehicles that no longer have the mechanical connection. So look, we'll use that RZ. I think it's a 350. I think it can be a 452, but it's the RZ with the steer by wire system. That system will look at the yoke, and similar to what Lexus already developed, it'll look at your yaw sensor, it'll look at your vehicle speed sensor. It'll basically try to understand what you're looking to do. And if you're just on the highway, this is a very fine tune. But if you turn like this, remember there's no steering shaft. There's no gears. There's no gear ratio. There's just your yoke basically being read by a sensor, or multiple, by the way, which is talking to an ECU, and the ECU is literally moving your rack and pinion. So they can program it so that if you turn like this with your yoke, it'll actually run the rack all the way to the steering lock. So you could literally do this and whip a tight U-turn because you're at 5 miles an hour. So they know if you turn this much, you mean business. Whereas if you're at 60 and you do this, they could make that just do an incremental, like avoiding debris in the road. So depending on your speed, depending on how they program it, they can do some amazing stuff with the steer by wire. Now let me give you one more reason that system's most likely gonna come to stay. Everybody is trying to find the next big thing that people are going to want. And one of the possibilities is full self-driving vehicle. So if you go to that full steer by wire, think of what the next generation vehicle may look like. You don't even need a steering wheel. They've developed cars already where if you want to drive yourself, a steering wheel pops out and you steer it, but it's not a steering wheel. It's really just a wheel that moves to signal a sensor, kind of like what I'm saying on this RZ. So they're already developing that. And some people are saying, why put the money into that? Who cares? Just put a steering shaft in there and make it work. Well, remember, they're looking way in the future. So if you're going to eventually get to the car where you press a button and a steering yoke pops out and you can steer it, but then you're like, forget this, I want to take a nap, push a different button and pass out, the steering wheel will go away. You can have room to put your feet up, and the advanced driver assist system can do a full self-driving. It's easier for it to steer your rack and steer your wheels. There's no, it's already all built in. So this is kind of the trend. The negative is you don't have a backup. So if this system fails, if that sensor fails, it's going to go into a mode. You guys got to be able to hear that car beeping. It's going to go into a mode where it doesn't know if your sensor is working or not. So it's most likely just going to stop the car, right? If it can't be sure that you're safe, it's going to stop the car. But we've already done that with brake-by-wire. So if the brake-by-wire fails, you don't just rely on like the master cylinder. That's all kind of gone. If the system fails, it disables the car, but that's kind of the trend. I personally don't like it, but there's a lot of benefits coming in as far as self-driving to go to these drive-by-wire, steer-by-wire, brake-by-wire. It's just further and further making it so the car can drive itself. So it's coming, whether you really like it or not. All right. And then if you also consider the way that things are going, the more that they can go to the by wire things, there's a lot of opportunities for, let's say Toyota gets into a business of providing transportation service. They can dispatch the car from their facility to give someone a ride from A to B. So basically, they take all of Uber's business, they would take all the taxis' business, they would take up a lot of people's business, and they wouldn't have to pay anyone to drive the car. The car drives the car. Kind of makes sense. There'd be a lot of people willing to do a subscription rather than have to pay for a car because they still have access to get wherever they need to get to, but they don't have to maintain a car, they don't have to purchase it, they don't have to insure it, they don't have to do anything. So this is kind of the direction we're trying to go, and steering's one of them. All right, so we'll continue. Now, four-wheel steering, something you're pretty excited about, I think. Not real common, but it's possible. So there's two types. There is passive, and passive is basically like Honda was doing in the Prelude. It's a compliance bushing. If you go around a turn to the left, the bushings are loose enough where it'll actually allow the wheels to turn slightly to the right, and it'll help the way it handles, help you do tighter turns. That's a passive system. There's nothing really to it except for flexible bushings. An active system is when we're actually actively steering the rear wheels. So there's been a few of those systems in the past. We do it kind of in a weird way. Let's say, for example, this one. This was made by Delphi. Here we've got a rear axle. We're literally bolting a rack onto it, and the rack has tie rod ends, and the rear end has actual knuckles. So we're steering the knuckle in the rear using a rack, but this rack is 100% electrically controlled. There's no steering shaft, there's no nothing. We're going to basically send it a signal and say, turn this way or turn that way. There's a little more to it than that. But we want to get to that when we're actually at the power steering, because this is basically an extension of electric power steering. Speaking of power steering, here we are. Here's your first power steering type. The RX and LC. Yeah, we'll talk about those. Here's your power steering assist. All the same players, right? Steering wheel, column, steering shaft goes to the rack, but now we add some players. Power steering pump, which has a pulley. The pulley is driven by the belt. The belt is going to generate pressure. The belt is going to turn the pump, which is going to generate pressure. We're going to send pressure down these hoses to the rack. and we're going to utilize that pressure to do work. So here's what that could look like. We're sending pressure from the pump to this control valve, and the control valve says, oh, we're going to turn left. And then look, the control valve sends fluid to this side of the piston. This side of the piston pushes on the piston and actually moves it in the housing, and that helps to run the rack. So your steering wheel is turning a shaft, which is still turning this pinion, but we're giving a whole lot of assist. So if you turn the car off, your steering wheel will still turn the pinion, which will still turn the rack. But as soon as you start it, you're getting a big boost of pressure. And that's why when you run the car and power steering's running or wah on a hydraulic system, all of a sudden it's like, oh, the steering's easy, right? Now you can see the fluid's getting sent to an actual power piston. And then remember, there's a seal over here, and that's one of the seals that'll leak and cause the rack to leak. There'd be a seal over here, a seal over here. Those would cause external leaks. We could actually have an internal leak on the power piston, and that would just give us poor assist, a hard steering concern. It wouldn't leak externally. So that's kind of how we do it. Now we can show it in a few different ways. By the way, we send the fluid pressure in the red. By the time we're done with it, we basically depressurize it, and it becomes return fluid. And that's non-pressurized. So that goes back to the pump. The pump sends the pressurized, we manipulate it, make it do work, send it back to the reservoir non-pressurized. Cool, so there's a pressure and a return in this system. And then as we get more into power steering, we're gonna do hydraulic, electric, and fully electric. But this one right here, electrically powered hydraulic, that one's a little bit tricky. So like for example, older cars would use electric and hydraulic to do it. It's really strange. I'll show you one. But on that on the regular hydraulic, here's that piston we were showing. Like right, if we back up 2 slides, here's that piston. We're using our force to move that piston. If you want to go to the left, we'd actually bring fluid over here and push the piston to the left. So it can go either way. A thing to remember is, remember the rack is still being moved by the steering wheel, but we're not really putting a lot of force on it. We're moving the steering wheel to control a valve. And then we're using the pump to actually push on one side of the piston or the other side of the piston. So it's kind of fun, an interesting way to do it, right? And now this is more just showing like, if you're not doing anything, there's going to be really no piston movement. If we were to put gauges on there, you'd actually see the pressure would be the same on both sides. And essentially what we're doing is we're opening and closing valves. So the control valve opens a valve or closes a valve. If we close this valve, pressure is going to become high on top, and we open this valve, pressure is going to become low on the bottom. What's that going to do to this piston? You have low pressure on the bottom and high pressure on the top. That's going to move the piston down. So you guys can see, if we tie that back to here, we would provide high pressure on the left, low pressure on the right. That's going to move the piston. But how do we do it? We close this valve and we open this valve. Cool. So this is all controlled by the control valve. And in this case, the control valve are these 2 black lines. Close here, open here. That gives us the downward. Cool. And so the control valve basically sits right here. It opens and closes. It can send fluid on one side of the piston or on the other side of the piston. And control valves can actually fail. So like in this case, it's sending it to the right side to move it to the left side. Cool. But I'm going to show you a picture of a control valve, and I want you to remember what the control valve does. It sends fluid to one side or to the other side, and they can fail. Where's the pressure come from, though? Comes from the pump. So the pump is driven by the belt. The belt spins a shaft. The shaft is going to spin a plate, which has a bunch of vanes on it, if it's a vane design. So these vanes are basically scooping up fluid at the suction and squeezing it down to the discharge and basically pushing it out the discharge. Scooping it up in the suction, pushing out the discharge. And that's why when your engine starts and the power steering pump starts to run, it starts to actually build pressure. Pulls it from the return, pushes it into the pressure. And then little reason that we need this reservoir is because when the pump starts, it's going to try to pull. It always needs to have a good amount of fluid to pull into the pump. If we're running low, it's going to start to pull in air. If it pulls in air, have you ever heard what that sounds like? It sounds like dying whales, kind of like, it just sounds bad. You lose pressure. So if your fluid's aerated or you're pulling air in, it's going to lose pressure, kind of like with brakes, doesn't make as much pressure, and you're going to have hard steering. So you get in a car and you have hard steering and you hear noise, and then you're going to probably want to check the reservoir, see does it have enough fluid. If it's low on fluid, you got to at least fill the fluid, turn the wheel some, try to bleed the air out, and more than likely it'll quiet down, and then you're just chasing, why did the fluid leak out, right? Whereas if you add the fluid and there's no air in it because the fluid's not aerated or something, and it still doesn't make good assist, these vanes don't really like it when they run dry. So these vanes are running across the housing, and the fluid does the work, but the fluid also cools and lubricates. And if these vanes are run dry, you're going to wear them out. So running a pump dry can also make a pump bad. If the pump is no good, it can't build pressure. Madi, good question. I got a couple videos on that. So when we do remove the air from the system, there's a couple techniques. I don't want to cover them because I do have videos on them, but that's the reason we need the air out. It's going to prolong the pump, and it's going to give us the proper pressure. Cool. And then I actually skipped one. So this is just kind of showing a flow valve. Let me back it up. There's a flow valve right here. That's what we're talking about now. Now the flow valve, depending on what we want, could give a little bit of fluid pressure or a lot of fluid pressure. So if you're driving down the road at 70 miles an hour, do you want a lot of power steering pressure? Because that's going to make it probably a little twitchy. No, you probably want less pressure. So we have these flow control valves that can actually make it so when we're at high speed, the pump doesn't work as hard and the pump doesn't make as much pressure. That's what this valve's all about. There's not a ton of, in fact, we're not really doing much with this anymore, but this used to be like a really big high-tech thing. We put in the flow control valve, and it was electronically controlled, and the ECM controlled it, and the ECM referenced the vehicle speed and all sorts of stuff. But just so you're at least familiar with electronic variable power steering pressure is that flow valve. All right, so now about there's a couple different types. Okay, so this is another type of varying flow. We actually had a hydraulic reaction chamber, and that would affect the pump's pressure. So if we were at low speeds, the pump would send max pressure. But if we got up to high speeds, this hydraulic reaction chamber would start to absorb some of the fluid pressure, and it would make the steering feel heavier. So light steering means a lot of pressure is being made. But then if we start to lower the pressure, depressurize it, the steering will feel heavy. So we did do that for a little while with this reaction chamber. We could do stuff in several different ways. And so that's kind of what this was showing, right? Now, talking more about diagnosis, generally this is what you're going to run into. A lack of assist. That's the number one, right? Not necessarily binding. Now we're talking two different things. So that customer that came in with the Astrovan for me, that wasn't a lack of assist. It was written up like that. The power steering is stiff was like, it sounds like a lack of assist. When in reality, that was a full-on mechanical binding, right? A lack of assist is more like you can steer it, but it doesn't feel that much easier than when it's off. You can turn the car off. You can steer lock to lock. It sucks. Then you start it, it should be easy. But like If it's a lack of assist, you start it and it might get a little easier, but not much, or maybe not at all. That'd be a lack of assist. Cool. Excessive assist, I've never had as a concern, but excessive assist would mean it's constantly pumping max pressure. So the steering wheel never gets heavier at higher speeds. That one's not real common, but external fluid leaks is real common. So you're probably dealing with a lack of assist because the fluid leaked out, and you can fix the lack of assist by filling the fluid and fixing the leak. Probably fix the leak first. Cool. So those are common. Checking the fluid level. There you go. It should be cold. It should be at the cold line when it's cold. If you fill it to the hot line when it's cold, by the time it actually gets hot, it might actually spill over. And now you have what appears to be a leak, but it's not a real leak. It was an overfilled that you did. So that would be no good. Right. And then these reservoirs are nicer where you can actually shine the light through and see them. You don't have to pull the dipstick, but different types. They all have hot and cold. It's fine if it's in the range. We don't necessarily need it all the way super topped up, right? In the range is good. We could also check the belt out, right? So let's jump here real quick. If the fluid level's low, you're probably expecting a lack of assist. If your belt is cracked and slipping, you're probably expecting a lack of assist. Both of those could cause lack of assist. Now, if your belt's just cracked, but it's not slipping, it's not really going to cause anything. That is until the belt breaks and then you lose all of your assist. But most vehicles, as we can see, I thought it was right there. I guess I forgot. I got the belt inspection coming up in a minute. But if we have a belt that breaks on a serpentine system, we're losing everything. We're losing power steering, alternator, water pump, sometimes AC. It's all gone. So we do the belt inspection as part of power steering, but it should really be done for any of those: air conditioning, electrical, all that. Cool. And then if you really need to diagnose power steering, I'm going to tell you what you're supposed to do. You actually put these gauges on, and I'm going to show you the gauge in a bit. You'd actually put gauges on, and you can open and close this valve to measure how strong the pump is. So if you close the valve, that's called deadheading the pump. That tells you the maximum pressure that pump can generate. That's a quick way to check the pump. If you deadhead it and the pump makes good pressure, the pump is good, then you can actually move on to really troubleshooting the steering gear. The truth is, I've never really seen anybody use this in the shop. Generally, we can pretty much figure out what's going on based on the noise and based on the symptoms. So, for example, we've had vehicles where you have good power steering assist to the left, and it's hard to turn it to the right. A pump doesn't cause that. That would be the control valve that's located in the rack. We've also had a power steering with low assist and the pump is whining, wow, 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 but it's not aerated and the fluid's full. That would more be a sign of the pump. We've had the one like I had the Astro van where you go to pull in the parking spot and it doesn't have good assist, but if you rev it up, the assist increases. That's a very typical sign of a power steering pump that's getting tired. So this is not real commonly used, but the fact of the matter is, if you really want 100% diagnosis, you got to hook these gauges up and you got to do some testing. Cool. So I'll show you a picture of what that looks like. That's at the very end. And then if you want to talk about flushing the fluid, let's say bleeding the air, or also if you had a pump fail and you had to get all the fluid flushed out, you could do this several times. Raise the wheels, drain the fluid. You're going to suck up the dirty stuff, turn it lock to lock to lock, and then remove the return hose, put it down into a bucket, cap the reservoir return port so it doesn't leak out, fill it with fluid, start it, run it. It's going to shoot all the old fluid out and it's going to suck the new fluid in, right? And then run it till it's low but not empty. Stop the engine when the fluid starts to flow, and then it'll basically get some of it out, fill it again, run it again, fill it again, run it again until clean fluid is flowing out of that return line that you have stuck in the bucket. Cool. Then you're going to make sure it's full, button it all up, turn the wheel several times is mostly how we bleed it. And then that would be how you do a power steering fluid flush. When would you do it? It would usually be after catastrophic failure. So if your pump goes bad and there's metal in the system, you're going to have to really flush it out good, type of thing. And that's right from Toyota. Now the bleeding, I'll do it briefly. Forgot I did put this in there. Make sure the fluid level's full, start the engine, turn it lock to lock slowly at least 4 times, verify the fluid is not cloudy. And then when you turn the engine off, it shouldn't come up any more than 5 millimeters. If it comes up more than 5 millimeters, it means air is lower in the system. And that's why I made the video. We've had some air stuck in the system that's hard to get out. We could actually use a vacuum pump to draw it out. It's kind of cool. Definitely watch the video. All right, now this gets into more about like the fluid lines and the fluid and the lines. Okay, now some manufacturers say recommending flushing the fluid between 50 and 100,000, but a lot of the times you won't find Toyota specifying that. Again, you would be flushing the fluid after a failure, more than likely. Or it's on sale and BG or Mach is giving bonuses for power steering flushes. Even electronic power steering systems need power steering fluid flushes. Just ask the service advisor. They'll sell it, right? So it's kind of funny, but and also true. Now hoses can fail over time. So if the hose leaks, if the hose seeps, if the hose has any sort of fluid loss, we replace them. We don't fix them. We don't. They're crimped. They're one-time crimped. Boom. If they're leaking, we're done. Right. And they can be exposed to the air, so they can dry rot and crack and stuff. So if you start to see them cracking, that's when I'd start to probably recommend it. But if it's leaking, you'll see them being wet. And I saw that question about the power steering fluid. You check the service manual, and if the service manual calls for a power steering fluid replacement in the manual, let me know, but I don't commonly see it. Okay, and then a lot of times power steering hoses use an O-ring. So if you pull a power steering hose off, make sure that you pay attention. Was there an O-ring there? Is there an O-ring there? If an O-ring was there, the O-ring needs to be there when you finish the car. Okay, they don't just seal. We don't use Teflon tape on the hoses. Okay, so, and we're using hoses to connect the pump to the rack. That's basically the only reason we're there. The engine moves around, and so we need something flexible to get the fluid from the moving engine to the frame or body rack. Cool. But because they make heat, a lot of times we'll use an oil cooler. So the line may go from the pump to the rack and the rack back to the pump on the return, but it also may go from the pump to a cooler, from the cooler to the rack, or from the pump to the rack and the rack to a cooler. So the cooler may be somewhere in the circuit too. Cool. And so the lines are not exactly rocket science. One of them is going to be high pressure. That's the one that's crimped. It looks very heavy duty. And one of them is going to be return pressure. That's the one you may actually see slid on and hose clamp. You could actually fix the hose clamp one. Like if you had to put a little piece of a new piece of rubber hose in there, if you get the right hose, you could fix the return one. But if it's the pressure hose, we replace the hose. We don't add a new clamp, and we don't do that. Cool. Now look at this valve. This is a control valve, right? This is the valve. Remember back in that picture I was saying we send the fluid to the left or we send it to the right? This is the control valve that does that. And what we have right here in red, those are kind of like O-rings, but they're actually square cut, hard Teflon rings. That's our sealing ability. So we send fluid pressure into there, and we need the seal to seal. And then we're going to send it through the holes from one place to a different place, depending on which direction we want it to go. But if these hard rings start to leak, you'll start to drop pressure, and that's when you'll get, it gives good assist one direction, not the other direction, or maybe not at all. So these do fail. Back in the day on Ford, for whatever reason, the rings were common for failing and they'd make the fluid really dark. And if you pulled one of those apart and you saw dark signs of the fluid, it was most likely these Teflon rings. And you'd end up replacing the pump and the rack and the whole system and flushing it out. So these rings could fail. But again, all this is really hydraulic, and we're going with less and less hydraulic every day. So for what it's worth, you can see them pretty well there. This actually even has some debris on it, right? So that would need to be cleaned, but these are the rings. If you want a rack rebuilt, this is one of the things that the power steering specialty remanufacturer is going to do. Fix all these. They might have to even clean up this valve and maybe machine it or replace it and put new rings on there. And it's just different stuff than what we really do. Cool. All right. And so that's really all talking about the flow control valve and that's what gives us the left to right steering. And so here we got another type of valve that is going to be more for, this was the control valve. And then this is the flow control valve, which can lower our power steering pump pressure or raise our power steering pump pressure. We also don't really rebuild these. If you have a problem with this, we're basically replacing the pump. Cool. So that's pretty much as far as we need to go on that. Now, here's one thing that you should know. Power steering pump, when you start to steer, it takes a lot of energy. It puts a lot of strain on the engine. If you have an engine idling at 800 RPM and you start stealing, if you start steering, is that gonna put some strain on your engine, and what's that gonna cause? How are you gonna know? What are you gonna hear? It's idling at 800, you start steering. What do you think might happen? It does make the idle raise. The reason it makes the idle raise is if enough fluid pressure hits this valve or this pressure switch, it's going to send a signal to the ECM, and the ECM is going to say, hey, bump the idle up. The ding dong is steering again. Cool. So that's basically all of what this is. That's it. It's just so the car doesn't stall. Now, if that switch doesn't get connected, your power steering will work fine. But when you go to steer, your engine may be a little bit low RPMs. It may stumble a bit. So if the customer says, yeah, when I steer, it feels like it's going to stall out, you may need to inspect that switch and the connections. Marty, your question is, this is in the pump. The actual control valve is in the rack. Cool. Or the power steering gear, the steering box. All righty. And now, if you just think about the ECM, that power steering pressure switch is just an input. It's just like, I'm doing my thing. Oh, all of a sudden that power steering pressure switch shows ground. That means I need to bump my idle up. That's it. Super simple. That's why it's one wire. The switch either grounds or it doesn't ground. If it grounds, that means it's high pressure. Bump the idle up. If it doesn't ground, don't bump the idle up. Cool, simple. Okay, and then this kind of talked a little bit more about the control valve. They may also call a rotary valve, but control valve and rotary valve are going to do a very similar job. Now let's jump into EPS. EPS is something that I do want you to understand a little better. So if we're looking at, let's say, for example, this type of rack, this has a couple things: a torque sensor, a temperature sensor, and an angle sensor. All these sensors are there for the system. They're going to give feedback to the electronic power steering control module. So if all these sensors are given the right feedback, we know how hard is the customer trying to turn, where is the customer trying to turn with relation to the steering wheel angle, and what's the temperature, because this is the motor right here, and you can actually overheat these. If you wanted, you could steer and 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 steer, and it'll actually go into a protection mode. We've had customers with that before. They would come in right around Black Friday. They'd be driving around the mall trying to find parking. For so long, they'd actually overheat their electronic power steering. And then as you can see, it could be a motor mount, a rack mounted motor, or the motor could be up at the column. This was really common, and now we're mostly moving them out to the rack. And this is the control module. So either way, the control module, those can be mounted several places, but the motor to give you the assist can be inside or outside, right? So if you think about this, why are we using it? Electric steering is more economical, it's cheaper, reacts faster, it's lighter, more compact, less parts, going to require less work, less maintenance. And then also what I was saying before is remember, they're constantly trying to invest in technology that's going to help them get to self-driving. Cool. So they're not investing in power steering that's hydraulic anymore. That's just not that's not the future, is what it is. So it could be the column, it could be the dual pinion, it could be the rack assist or the direct drive. It could be quite a few different types. And then when we say the active control, what that means is there's going to be sensors giving feedback to the control unit so it can fine tune what we're doing. It can react to the road, the weather, the type of driver. These are some of the cars where you can put it on sport mode and get a heavier, stiffer steering, or you could put it on like touring mode and get a nice softer steering. Right? All these are possible with electronic power steering. And as you can see on the actual rack, we have a couple different ways to do this, but we'll do a torsion sensor, and that feels how hard is the customer trying to turn it. And if they're trying to turn hard, we should boost up the assist by running more amps to the motor. Cool. So that's kind of what this is. And you can see it mounts just like a regular one. They just tend to be a little bigger. And so getting them out can be a little tougher. The positive is you don't have to worry about fluid because they don't have power steering fluid. So they're neater, but they're definitely chunkier, heavier, and they can tend to be a little tougher to get out. There's a good chance you're going to have to drop the subframe most of the way, if not all the way out. All right. And then you can see here, again, looking at that sensor, looking at the motor itself, looking at the temperature sensor, and then the rotation angle sensor is going to be built in. And that, when we do an alignment, we may need to reset the steering angle sensor. That's the rotational angle sensor. It very well will be on the rack. There's some that's up by the clock spring, but a lot of them are down on the rack. If we do the alignment, we're resetting that sensor. Cool. Or if we replace a rack or a control module, we may actually have to do a full relearn on all these because it doesn't know what zero torque is, right? So we may have to do like center the steering wheel, take your hands off it, click the button, and it learns what zero torque is and what straight ahead is. It'll learn both. So there's a little bit of a process there. And then this is a resolver. So this is where we're going to get the position and the torque, right? So especially the torque in this case, it gets a little bit technical as to how we're going to do that. And there can be a couple types, but it's literally measuring how much force the driver is putting into it, which becomes a signal to the ECU, which becomes a command to the motor. Cool, have fun. And then this is that one I told you I had one slide on. They did have, this was a dumb idea, I think. They did have an electronically driven pump that used fluid to power a rack. So they didn't have an engine driven pump. They had a motor driven pump to run a hydraulic rack. And it was sort of like, why not just go all electric? And Colin says in the chat, hydraulic feels better. I don't know. I'm not convinced, especially some of the ones with electric that you can adjust how it feels. They can make it feel pretty in tune, actually. But you may encounter one of these. If you do, let me know. I've actually never seen it. So kind of fun. Now, here's really the important part. EPS systems require only 2% of the engine power that a belt-driven power steering pump uses. Remember, the driving force, right? We're trying to get better gas mileage. We're trying to get lower emissions. We're trying to get cars that can self-drive. You're not going to see any investment in hydraulics. It's just not going to happen, even if it feels better. So you say. All right, so they will do quite a bit of you know, they will show quite a bit of reasons why they want electric power steering, but this is a big one. It's 98% more efficient. So kind of crazy, right? And then here's one that's a different style than what we see. This is the motor mounted to the rack in a different design. So they can look quite a few different ways, right? The only problem I've seen with these is these connectors are kind of hard to get out, but you'll make it happen. So basic explanation. This is a lot of words. I'm gonna help you. You could take a look at it for a second. Picture's worth 1,000 words. Here's your power steering control module. Your power steering control module needs to have inputs, right? So your power steering control module, like your brain, is looking at its senses, right? Feel, touch, feel and touch are the same. Smell, hear, and vision, right? So those are the senses. Well, those are the sensors. So what it's sensing, position, where is the steering wheel? And torque, how much force is the customer putting on it? So those are the sensors. They provide input. That input becomes, I see. This input, I was reading what you're saying about the track conversions. This input, those inputs will go to a processor, like a microprocessor, and those processor can be programmed in a certain way. So if you have this amount of torque and this amount of position, that will send a signal to another part of the ECM, which will say, okay, I'm referencing my programming. What I'm supposed to do is send 12 volts to here and ground to here, and it can vary the amount of amps it sends, right? So if you increase your pressure, the computer will basically see that voltage change and therefore increase the amperage to the motor. Then if you decrease your pressure on the torque, it'll see that change and it'll decrease the amperage to the motor. Or then if you all of a sudden, boom, throw the other direction, then it'll say, oh, they changed directions, and it will not only change the amperage, it will actually send 12 volts to the other side and ground to the other side and modify the amperage, right? So it's kind of like your brain. It's looking at sensors, it's looking at inputs, thinking about it, except it's not artificial intelligence. It's very dumb. It just follows the programming that it was given by the people who designed it and programmed it, right? And then it controls the motor as it sees fit. So if we had a problem with one of these sensors, you can anticipate it's not going to control the motor correctly. If we had a problem with one of the sensors, more than likely you're going to get a DTC. And then you're just going to be diagnosing DTC based diagnosis. Not that big of a thing. If you get a code, how do you know? You get an electronic power steering service, some sort of light. PS, EMPS, EPS, some light is on. That means a code is set. Just like ABS, if an ABS light stays on, a code is set. If an EPS light stays on, a code is set. Check for codes, troubleshoot the code, troubleshoot the DTC. You replace the parts, you may need to do a relearn. You can do that through the scan tool. Not a real big deal. One of the reasons we like this is because if this electronic system fails, no problem. You got a steering shaft and a steering column and a steering wheel. You can still steer it. You just can't have power steering. So it's pretty foolproof. You know, if it does fail, you can still drive. The drive-by wire is different. The drive-by wire has redundancy. The steer-by-wire, I should say, has redundancies. Double the torque sensors, double the position sensors to make sure they agree, to make sure it's not going to do the wrong thing in case of a failed sensor. There's always two sensors checking against each other. If there's any sort of non-correlation, it sets a code, the car won't even move. You're done. Period. Because it would rather have the car disabled than have you try to steer left and it goes right and kill somebody. Make sense? So these systems are a little more going to be more widely accepted because we still have a backup. Cool. But if you think that people aren't going to eventually accept the steer by wire, well, most of you have ridden in airplanes. Most people ride an airplane. that's 100% by wire. There's no connection to any of the stuff in airplane in a big like a Southwest or something. So it's coming, whether you like it or not. Right. And the column mounted EPS system pretty much works the same. It's just the motor's right there, like 2 feet from you, and you do tend to maybe hear a little bit more, and they tend to be a little harder to cool because they're in the cabin. Cool. So this is the column with the motor hanging off the side. They're a little awkward if you ask me, but they work the same. Everything you learned the same. This will actually give the torque reading. So this is the same thing. It's like a force sensor. They could do it in several different ways. It'll use detection rings and magnetic fields with the torsion bar going through. So exactly how it makes the voltage that indicates the torque, I don't really know. I have enough of an idea where I can more than diagnose it. All right, but the people who design the sensors, they design the sensors. We interpret the sensor voltages to determine a fault. We diagnose it, we calibrate it. It's kind of what we do. Cool. And then you can have steering angle sensors that are up at the column too. So sometimes the steering angle sensor's at the rack, sometimes it's high up in the column. And again, when do we need to relearn it? After an alignment, after you replace a steering gear, after you replace a steering column. Potentially, if you have some major collision and it needs substantial adjustment, if you replace the power steering control module, yes. And sometimes if you do a electronic, like an ABS module, skid control ECU, you may also need to relearn it. So there's plenty of times we'll need to relearn these. The relearning procedure is usually not that tough, right? Fairly simple. Now, look it up, but generally you're going to have to center the wheels, put it in park, maybe apply the parking brake, connect the scan tool. You might have varying, information depending on what procedure you got, but essentially you're going to select steering wheel angle centering procedure one way or another. All makes and models, you're going to have to find something that's similar to relearn. And then it's going to tell you, probably like we said, steering wheel centered, in park, take your hands off it, click the button, and boom, you're there. Really easy. And then some of these are kind of interesting. This will do a dual pinion, so it'll have a pinion from the shaft so you can turn it, but it'll use a different pinion from the motor so the motor can help you. So it's, to you, it doesn't really matter that much. It's just a little bit of a different style. So it still gives us the mechanical backup, but it also gives us the assist we want. And then here's an interesting point. There are electronic power steering systems that use higher voltage because remember, power is volts times amps. Every time you want to increase the amps, you need to do bigger wire, bigger relay, bigger control. It's hard to manage big amps. It's actually easier in a lot of ways to increase the voltage. So if you did 12 volts at 50 amps and you wanted to decrease your wire size to save on copper costs, you could do 24 volts at only 25 amps. That would give you the same power as 12 volts at 50 amps. Cool. So if we can increase the voltage, we can decrease the amperage and still get the same amount of power based on watts equals volts times amps. Cool. So there are vehicles that can go up as high as 46 volts for electronic power steering. If it's regular 12 volts or 14 or whatever, it's going to be normal colors. If it's a medium voltage, sometimes they'll be colored weird, like blue. I don't see a whole lot running really high voltage. Like if it's over 48 volts, it's going to have to be orange. It could be up to 48, but if it's 48 volts plus, it's going to be orange wiring. I don't see any or many of those, but if we don't right now, we will soon. Because again, you can increase the voltage, you can decrease the amperage. It's kind of makes sense. So those will use a DC-DC converter. So if it is like, let's say a hybrid and the hybrid battery pack voltage is 237 We'll use a DC-DC converter to drop it to 42 or something. Cool. That's what we're going to do. Those, you're definitely going to follow the service manual quite closely. All right. Now, autopilot self-parking. Again, this was not really doable before electronic power steering. We didn't have a good way to control the steering wheel and the steering angles until we went to electronic. Now, remember how the system, right? If we back up here, we're looking at all these inputs. The inputs is looking at your torque sensor and all that. But if you think about it, ultimately, the computer is controlling the motor anyway. So we can say, you know what? Forget your inputs. We're just going to look at our programming and say, oh, the customer went ahead and they pushed self park. It can control the motor directly with or without you touching the steering wheel. Cool. So this is why a lot of this is the future. If you want the car to be able to drive itself, park itself, etc., electronic power steering lends very easily to that. And so it's going to use a lot of modules. The EPS is ultimately controlling the motor, but a bunch of other modules are communicating with the EPS. For example, forward-facing camera, that's its own module. If we're going to use sonar, if we're going to use radar, if we're going to use backup sensors, parking sensors, all those modules are going to communicate. It's going to stitch that information together, and it's going to give commands to the electronic power steering system to move left, to move right, to whatever. Cool. So it's pretty interesting. And then this was a little bit more about the Delphi four-wheel steer. So I know there's a couple other systems, but this was the one used by the book, and I didn't see a problem with it, so we kept it. This is the actual steering rack that's bolted to the rear axle. It is controlled by the module. The module looks at the steering angle. The module looks at the lateral, the yaw rate sensor, and it'll communicate with the ABS module because it needs to know vehicle speed. So those are the players in the game. This is where the module is located for the rear wheel steering. This is a control switch. What's kind of funny about that control switch is you can set it in a few ways. First off, you can turn four-wheel steering off. Secondly, if you want, like, let's say you're on high speed, at high speed, you want all four wheels turning the same direction, right? But if you're at low speed and you're trying to whip a U-turn, you actually want the rear wheels to turn opposite of your front wheels. That's going to give you a tighter turning radius. So there were some basic controls here that you could control, but a lot of it, the computer controlled based on vehicle speed and stuff anyway. So those are some of the players in the game. And then, you know, it did have all the sensors we have way back in the day, steering angle, torque, and then this is showing the actual sensor as well. So this is the what position the rear wheels are in. So this was a rear wheel position sensor on the rear axle, kind of neat. And then here's that whole assembly where it bolts up. Second time you've seen this picture, but helps you to sort of understand. Everything you learned about EPS perfectly translates to this four-wheel steering. That's the reason I cut it out and moved it later. Whereas if you follow the book puts four-wheel steering like close to the beginning, and you don't know much about EPS yet, so it doesn't make sense. So that's pretty much the system. It was a cool system, but to be honest, the main problem was this rack right here. The gears are made of plastic, so if you went to turn and the rear wheels turned and you were up against a curb, it wouldn't dent your wheel. It'd break the plastic inside the rack. All right, now that's the meat of EPS, and you can see there's a lot of material packed today. But it, like kind of like suspension, a lot of what you need to know is by doing the work. So rather than just tell you to do the work, I want to give you a few things to help you start on a good foot. Showing some tools. Remember we talked about diagnosing hydraulic pressures? This is the power steering diagnosis tool for hydraulics. A lot of adapters. You hook it up to both lines. You can deadhead the pump, see what pressure it measures. You can measure the pressure as you're steering. You can measure all sorts of pressures. Pickle fork, y'all know what that is. And then if you're going to do an inner tie rod, this is the inner tie rod tool. So I'll make a video on one of these. If I haven't yet, I don't think I have. Right. So as we continue, one of the main things you're going to run into is power steering leaks. One trick, you could use dye. Right. If it's hard to find the leak and you can't tell if it's engine oil or power steering fluid, and there's transmission fluid leaking and the fluid all over the place. And for the record, a lot of cars take power steering fluid, but some cars use automatic transmission fluid for the power steering. It can be hard to tell what's what. The dye is a good tip. Myself personally, I would degrease and pressure wash this whole thing, fire it up, and I can usually pinpoint the leak. Plus, it's clean, right? But there's different ways to do it. Another thing people have done is use powder. It's almost like flour, and they'll powder it onto a spot. And if it's leaking, the powder will get darker. And if it's not leaking, the powder will kind of dry it out. So different steps. Roberto, go ahead.
Just a quick question: is that dye the same dye that we use for like the engine oil checking for those leaks?
Engine oil dye, yes. There's different dye for coolant. There's different dye for air conditioning. But the power steering fluid, you could use the regular engine oil dye 100%. Good to go. Because it's petroleum. Petroleum dye is for petroleum products, power steering fluid included. Good question. Now, another thing, let's say that you're running into some of these steering issues, hard steering, binding, or whatever. Another tool that's good to use is literally just the grease gun, right? So this is usually covered in lube oil filter, but you know, greasing stuff can help us with diagnosis as well. Greasing stuff can help us in service. So if we're replacing parts, we need to remember that we need to grease these. Now, yes, most of the time, this is old school. Most of the time, the grease fitting's gone. They took it away. They sealed it, and you can't do anything. But there are times where if I'm looking at a steering issue, I'll actually, if I'm pretty sure it's that ball joint, I'll actually poke a hole with a pin. I'll put a grease gun in there, and I'll grease it myself anyway. And if that resolves, let's say, the noise, I know it's that joint. It's not fixed, but it's diagnosed. It's identified. Cool. So there's some good tips with greasing. Here's that power steering pressure tester again. And it can also, it's zoomed in, it can also measure flow, like in gallons per minute. So we can measure not only is the pump building pressure, but is it flowing enough volume? Another cool one, if you were to do, this is where the serpentine belt diagram is. I couldn't quite remember. If you're going to do work on the belt, most of the time our belt tensioner is going to be spring loaded. But if it's old school and we actually have to set the belt tension, this is what we call a belt tension gauge. So it actually measures like the deflection of the belt. I do this by feel, but I've also done a lot of them, so I can do it by feel. When you're new, it'd be good to just be familiar. There is a way to tell if the belt's too tight or too loose, and this is the tool. 90% likely you won't ever need this ever, because you're going to be working more like this. If you're working on a serpentine belt, this pulley is tensioning and it's spring loaded. Cool. So there's a picture in the book that was really good, and it shows the tensioner with a bunch of marks. And as the belt wears, it goes further and further towards this one line showing it's no good. But part of what that is, belts crack, but the newer belts don't crack so much. They really wear. So if you have this tool, and you can used to be able to get this tool for free on gates.com, but I think they stopped doing it. Gates, Gates, makes a lot of belts. You get this tool and you can lay it in there and see if it's worn. If it's almost like checking tread depth. You lay it down in there, and if it's buried in the tread, you're good. But if it's the orange is sticking up above the tread, that would mean the tread's kind of low in the belt. So, that's a tool. But we're going to find one, and I'm going to show you that the marks on the tensioner, because Toyota does do a lot of those, and that'd be probably a good way. And then just remembering a routing diagram is going to tell you which way the belt goes. They can be a pain to find. So like what I like to do, I'll take a picture first before I pull the belt off. Get a picture, pull the belt off. Most of the time I can remember. If I can, I go to my picture. If my picture sucked or I don't have it, then I'll go look it up. But I'm kind of wasting time. I'm looking it up. Cool. So that's a little bit of belt work. Another thing is, if we're replacing a power steering pump on a Toyota, they have holes in the pulley. So you can actually get the pump out without pulling the pulley. And a lot of times the pump comes with a pulley. But if it doesn't, and you need to swap the pulley over, there is a puller tool and an installer tool. And I have them at the school. We could do one for practice, but this, for example, is actually the installer. So the puller hooks this and you thread it in, and it will literally pull the pulley off of the power steering pump shaft. And then this one will literally thread in to the shaft, and then you'll spin this up, and this is a bearing, and it'll press the pulley back on. So that's a service you may perform. It's not real common anymore. And another note, when we're doing steering work, be sure you have everything torqued, and if it's got cotter pins are one-time use. So if you pull a cotter pin out, I'm not going to say you can't get away with reusing it and that I haven't done it myself a lot of times, but per what's right and what's wrong, you're supposed to replace cotter pins anytime you take them out. Cool. And then similarly, this is a castle nut, but if it was a nylon type locking nut, those nylocks, they thread down easy at first and they get kind of hard, and you have to tighten them all the way to torque, and that nylon binds to the part, and that's what locks it. Those are also one-time use. So just FYI, a lot of these locking type of fasteners are one-time use. Do I reuse the nylocks sometimes too? I do, but I'm not supposed to. And if I do and something goes wrong, it's my fault. So at least you know. And then here's the shot of doing that inner tie rod. The inner tie rod's long, and you need a wrench, and your wrench can't get way far inside. So you actually use a little adapter inside of this tube, and this tube becomes like a super extra deep socket. So you can get it all the way over the long tie rod end, and then get to the actual socket we need loose, and then loosen it up. So that's your inner tie rod tool. It's a pretty good one. Now, when we get into the SRS, remember, if you're doing something related to steering where the airbag is a concern, this is what we mentioned earlier. Disconnect the negative terminal, wait a certain amount of time because of the capacitors, maybe 15 minutes, maybe 5, maybe 10, I don't know. And then remember, don't use one of the battery, the memory minder type of thing to keep the radio and clock set, because those have enough power to deploy. So just totally let it go dead. And then yes, you have to reset all the stuff. And now you made it. So I'll get the lecture quiz ready. But first, if you guys have a good question that's going to help understanding, ask it. Otherwise, pause the recording. A super, super good question.